Hey, Cliff. Can you hear me?
Hey, Cameron.
Can you hear me?
I can hear you. Can't see you. There you go. You are still. Here you go. Here's Derek. Here's Alan. Hey, Derek.
Hey,
Hoping we'll
started the recording already.
Oh, sure enough. Yeah, welcome to Coffee Compiler Club. We just missed a great conversation about speculative parallel unzipping of gzip and anything else to do with compilers and language runtimes. And everyone's been recorded, and you'll show up on YouTube within the hour or a couple hours, or internet will fail or whatever. And that gives me this warning for y'all. Winter storm number 3 or 4 is passing over my house right now. Knock on, particle board. I've got my cable doesn't go out, but who knows? So if there's a sudden cliff just dropped, carry on, and I'll see what I can salvage out of the Zoom call later.
If that's the case, you should appoint a co-host so the meeting doesn't end.
Well, I always want to be Theodore because he's been long-term the second guy here. I have right. I don't know what Zoom will do. I'm the guy who pays the bill for Zoom. So if I drop, a Zoom may just say, ha, host is gone, you're dead.
Right, that's what I was saying. In the participant list, you should be able to right-click Tidor and assign him co-host privileges, and then the meeting won't end when the host leaves.
Oh, I didn't know that.
Oh,
I can make him a host.
Ooh.
There you go. I can, rename him, spotlight him, stop his video, put him in a waiting room. I don't know how to make him a backup host. Sorry, I'll have to hunt that one offline. Are we done with parallel G and zip? Just the coffee video won't have that conversation, so I wasn't going to repeat it and then start in, but we could. I don't care.
Well,
I think just leave it hanging there so everybody can wonder what speculative parallel gzipping is.
Unzip.
Unzip.
All right, 10 seconds. Then Alan.
Yeah, the best part of the conversation was, of course, when you unveiled all those hidden Intel opcodes. So we don't want to put those on the recording.
Right.
Leave them out this time.
The first rule about Intel opcodes is we don't talk about Intel opcodes.
Okay. So
I still think the main lesson there is when you are storing really giant files, be careful how you design those files.
Yeah, right. So the people would have, the customers for Astro would have giant gzip files, and many gigs, some headed for the terabyte range, like ludicrous sizes. And then there's no official way to unzip them. So it's serialized unzipping in theory, but we could speculatively unzip by starting in the middle and reading and crashing and burning until you found a keyframe. And then if the last unzip stopped at the same keyframe you started at, you were golden and you had a correct, valid parallel unzipping.
Does anyone here have opinions of headers versus footers when you're making a file format? Because I've seen a lot of formats where the header just has a pointer that says, here's the thing at the very end of the file that's got the metadata. And then you have to seek all the way to the end. And then you read the directory. And then you seek all the way back to the beginning to read the chunks.
Right. So OS is, deal with sync. Seek, it's okay. Right. They go check their itables and say, oh, seek meant this disk block, and you burn time for a disk block. Then you got the tail and you read it, but it was all small change compared to the many gigs you're about to go read. So the tail part, I don't care. I'll go find the tail and read it out.
And you think that's worth it so that when I have to add new data, I can just overwrite the end of the file and then write a new directory at the end?
Yeah, as far as I'm concerned.
Because most of the formats I've seen, they want to put the directory at the end, and the only things at the beginning is one pointer that says, here's where the directory starts.
Right.
Does this matter with SSDs?
That's what I'm saying. I don't really care because I'm going to seek. I mean, seek is not tape no more, right? So it's a big disk, not just SSDs, but standard spinny disks will seek to the end of file. in one
Right.
disk spinny time.
Yeah.
But if we're in
there's
HDFS
some
land, if I
penalty
jump
there.
by more than 64 megabytes, I'm going to land into different chunk and do network traffic. I'm going to read in the first 64 megabytes just to get the pointer, and then the last 64 megabytes to get the directory, and then I'll start reading chunks I care about.
In the land of H2O, reading multi-gig to terabyte files, these are all small numbers, right? I'm going to burn all the disk bandwidth in the planet to go get the whole file anyhow. So I'm just going to pay the price to get to the second guy at the end and read him. Then I'm going to probe the fucking file stochastically to figure out what the actual CSV format is. And then once I've got a few megabytes of stochastic reading going on and I decide what your format looks like, I'll then start the read in earnest. And people will do the right thing from there.
And if it's a giant file, that's worth it.
And if it's a giant file, it's worth it, yeah.
Didn't MP3 have this format where all the metadata was at the beginning of the file, and then you had all these limitations of how big the metadata could be, and it turned out to be a bad idea?
That one I don't know.
I'm not sure, but I know that
I know that MP3s go kind of wonky if you go over 2 gigabytes.
Oh, that would make sense. Being 31 bits, 32 bits, negative integers, and somebody got unhappy.
So you had a question for Arthur.
I did. So we had a conversation, Arthur, about the act of caching jitted code and caching profile data and serving jitted code across a cluster. And you were the guy with the experience, so I was wondering if you wanted to chime in. Oh, and you're not on Discord, so I couldn't ping you on Discord.
Yeah, so what we've done in this area, so first we have thing that we call compile stashing. That's basically a on-disk cache of compilations that can be reused from run to run. The way it works, what we do is we basically store the initial LLVM IR for the compilation, and we store all the queries that the compiler made to the VM. And then we use this as a key. So if the initial IR and all the requests are the same or like match, then we can reuse the result of the compilation. And that worked fairly well with one caveat, that the profiling differences would kill the match rate. And we had to basically, it was practical if, in addition to that, we also use the profile, and that's what's known as ready now. So if we reuse profile from a previous run, then profile is the same, and we can reuse the compilations. And the match rate was pretty good, and yeah, it saved some CPU on the compilations.
So how close does the profile data have to be?
So what we did when we tried to do this without ready now is we tried to do normalization of the profile, and there was some like balancing act between like trying to normalize it, let's say to normalize branch weights to powers of 2, so as to A, coarsen it enough to match, and B, not coarsen too much so as not to lose performance. So, and we do have some normalization by default for this purpose, but normalization never brought us to the level where the savings of that cache were good. And the second like interesting observation that wasn't obvious at the beginning, at least for me, we can have pretty high match rate, let's say like 80%, but it doesn't give you as much of savings in terms of CPU, like in terms of compile time and CPU utilization. And the reason is you will likely mismatch large compilations with a lot of inlining, just because the more you inline, like the more chances you mismatch. But they spend CPU, like there is like nonlinear growth of compile time. Yeah. So, and you need to have match rate like more than 90%, like close to 95, to start seeing some nice improvements of compile time.
We need to get Simon in here and tell him that one's. What you just said was it's hard to beat the JIT. You can, but it's hard.
It also depends on what kind of JIT you have. So LLVM is slow, and for us, all these tricks, yeah, they were worth it.
They pay off on LLVM, but not on C2. Okay.
Yeah, and then we have.
I was going to say, it's not always about beating the JIT, though, because the challenge with a profile-driven JIT is that you have to wait for the profile.
Well, okay, so this sounds like startup time issues. Is that what you're talking about? Like if I have a server that's running for days, the profile data was available eons ago, and I don't care.
So there are actually two different aspects that you can optimize. You can optimize for CPU utilization, and like things that are running in containers and things that can be throttling in containers. CPU utilization would be a bad thing, so you want to reduce it. And other thing, you can optimize for warm-up. And actually, you can sometimes spend more CPU in order to improve warm-up. This caching, yeah, it will definitely save some compile time and save CPU utilization, but warm-up will be dependent on, yeah, that you need to collect the profile, and this cache will not optimize this aspect. But as I said, because we're using this cache with reusing of the profile, this aspect is also resolved in this way.
So if I have like 1,000 machines that are all running the same code base, and I keep all of the statistics from all of them so that I can say, hey, when I do my very first ahead of time compile, do it in the way that works for sort of the average of what the whole data center does, except keep counts, and then do more specific optimization based on what's happening on that machine once you hit whatever 10,000 iterations.
So
I wonder how well that initial I compiled the thing with sort of average counters across all the machines does compared to this is the actual workload on this machine compiled version.
So what I described with reuse of profile and reuse of compilations, this doesn't do aggregation across different VMs. It's more of you have an application and you can save the profile from one run, and the next run you would start with the profile you had before.
And the application.
Yeah, and like historically, it was for like the trading applications. They interact badly with typical adaptive runtime, because these trading applications, most of the time they sit in a loop and wait for some conditions, and an adaptive runtime would optimize for sitting in that loop and say you never did a transaction, so I wouldn't compile it. So things went bad for them when they hit this transaction the first time, like, okay, we go and start compiling things, and then they lose their opportunity because they are time sensitive. So for them, this kind of, we remember the profile from one run, and next time you start, you already know the code path that you would execute. So that's the scenario this thing works well for. What we also have in progress at the moment is, this thing is called Ready Now. We also have Ready Now as a service now, and the idea, is to aggregate it across different VMs. And we also have a thing with what we call cloud native compiler, where the compiler is not on the local VM. So we can send compilation requests to a remote server, do the compilations there, and send the binary code from there. And there is another implementation of compilations cache there. It's done differently. I know less details about how this thing is implemented, but it also exposes similar properties of, like, you need very high match rate to observe good reduction in CPU spendings. And the second thing is, the idea is that if you have a cluster that runs the same application on multiple nodes, they are all served by this compilation server, and you can reuse the result of compilations for different nodes.
It's an interesting insight that sometimes the code you run most and the code you care most about are not necessarily the same code. No, I'm used to sort of web servers where the hot code is the code that you care about. But if you're a trading app, what do I do in the event of a flash crash code? I run very rarely, but really want that to respond quickly. Even if I only run it once every year and a half.
And in general, different like message processing systems, they would sit in a loop and wait like for message to come. And then what they care about is latency of processing these messages. And you can have rare messages, like happens every once in a while, never shows up in the profile. But since they measure the time to serve this kind of request, they would be unhappy if you didn't optimize this well.
Yeah.
This actually poses a challenge. Since we suffer from high compile time, we experiment a lot with different compilation policies. And what is interesting that it's actually hard to beat what there is in OpenJDK and Hotspot now. This very simple, like you accumulated this number of invocations or like this number of back edges, you compile it. Because once you start looking into like you profile things and you look at what is being executed, you would miss this kind of rare but important things. And ultimately, you can have an application that has one method and has a timer wrapped around this call and really cares about the time to execute this method. And if it doesn't show up in the profile, well, you won't be able to recognize it by just external observation.
You say when you profile, you mean in terms of statistically speaking across all hot methods, because the approach is another profile, but the counter approach just says 1, 2, 3, 4, 10,000 done.
Yeah. When I say profile, I mean like sampling kind of profile.
Yeah. Okay. Yes. We went back and forth on those. At one point, we tried one that was take the counters and degrade them over time, take the average of all counts and do a percentage reduction over time. So they had a exponential drop off kind of effect. Like you remembered only a little bit of the long ago history and very well precisely the current history, but because of the counter decay, older history kept fading away from you. And the goal was to say that we will stop jitting at some point because these things are just too rare. And that never worked out well. We dropped that at some point and we just said, just count. And when you hit 10,000, and that means eventually you jit everything very slowly. And the jit never really goes to bed. It just keeps tickling in, but it doesn't miss any of these funny cases that you're talking about where a rare event I want to have some good latency on. They eventually get picked up.
Yeah, what we came to is you can use this kind of things for prioritization. You can choose to compile first things that show up in sampling, but then you want to eventually compile everything that reaches some threshold.
Yeah, it keeps getting touched. Yeah.
So my understanding was a lot of the win of the JIT was that it was doing things like looking at a megamorphic call and realizing 90% all went to the same thing.
I mean, they're right. There are two different things I thought was a win. One was you got good startup time in general because you started interpreted and then you kicked the higher order shit into the jitted mode. And the second was you had profile data, which fed into a lot of optimizations.
Well, that was sort of my question. If for the code that I care a lot about, but doesn't run very often, it has no megamorphic calls, you should be able to generate nice, fast code there.
Yeah, it's like a GCC
with no metrics.
You'll duplicate it.
But you can't start a JVM with like ahead of time try real hard mode that says, go crawl the code base and compile as aggressively as you can before you start processing anything at all. Can you?
And it sucked. We did, and it sucked.
But the way current hotspot heuristic works, where you need to accumulate some number of invocations before it is compiled, it actually provides you with a profile. Like you executed this method 10,000 times, you will have this number of like samples in your instrumented profile.
It's like an attention. It's like an attention mechanism to zoom in really on the parts you carry. You execute a lot.
Okay, in that sense. It does guarantee you a minimum quality of profile before you begin jitting. So the problem with this XComp mode, which we had plenty of old school guys say, have it, do it, use it, and they tried it, was that the JIT compiler had no profile data. So he fell back to static C heuristics. And that was substantially worse in the context of hotspot as opposed to C. you had all these runtime tests that were all junky and never failed. And if you knew they weren't going to fail, you care to do something different or whatever. So we tried, and a lot of debugging happened with XComp because it made life very deterministic and easy. But it was very, very slow, especially to get started, and very, very low performance relative to the jitted code.
But I would think it would still beat the interpreted code.
Well, startup would not beat the interpreter, but runtime would beat the interpreter. But the deal with the jitter is with profiles, he does the inlining right. And with XComp mode, he just compiled everybody. And when he came to a guy to go to compile, he used static heuristics to decide inlining or not. And then he just didn't get the right inlines in, and he didn't have the static information he needed to go clean out all kinds of exciting loops. And so your code quality just suffered across the board. And it was maybe suffering more because it was Java instead of C.
Yeah, I think it's not an exact number, but roughly, let's say 30% of performance is what we get from using profiling information. So if we run without C1, and that's where we collect most of the profile, that's the drop we get in terms of performance, roughly.
Yeah. Is this an LLVM as well, or C2? I know C2 takes a hit.
LLVM as well.
Yeah, LLVM as well. Yeah, okay. Yeah, fine.
And yeah, the more dynamic features you have in your language, the more you would need this kind of adaptive behavior in order to get speed out of it.
Yeah, okay. That was information that I had known back in the day or was observing on the spot, but I hadn't touched base on in 15 years. So
does anyone know what happened to the Crystal project that was trying to statically compile Ruby ahead of time?
I think
it was a crazy dynamic language.
Let's see,
There's a Crystal Lang. Are you talking Crystal Lang or something else?
Yeah, I think it was Crystal Lang was the staticky Ruby.
You throwing this in the docs?
I don't know. I mean, that's still around.
That
They're
stuff,
actively working on it.
Yeah, Crystal's the one out of Brazil, right? It's a team in Brazil building a language. Yeah. I think they got to their 1.0.
Crystallang.org. I'll just throw the link in the doc, but I haven't looked at it at all.
I think Ruby itself released a major performance update release this Christmas. They always do the Christmas release, right? That's their thing.
Oh, Crystal syntax is heavily inspired by Ruby's. So it feels natural to read and write and has the added benefit of the lower learning curve. It's not the same language as Ruby. And is statically typed, not the same language as Ruby. That's interesting. And I'm reading about all the power fails running around up in the mountains.
But yeah, I see products like this that are like, oh, let's take this very dynamic thing and make a static starting point. If there's a way to have a very dynamic language and say, okay, for this critical section of my code, make everything static and well-behaved and the kind of thing that I can ahead of time compile really well.
This is where
then I can do an ahead of time compile before runtime that still keeps the counters. And then the JIT, when I hit the 10,000th one, says, okay, now I'm going to replace my ahead of time well-compiled thing with a potentially better JITted thing.
All right, one more thing on my bucket list for AA.
Is a good ahead of time compiler?
The ability to cache profiles that are reusable without breaking. Like I heard Arthur say we had real trouble, especially with the bigger, slower compiles, getting the profile data from run to run, matching the state of the heap and the JIT, and like this is a Java class issue, at least in part, matching well enough that we could just reuse the code. Like on this run, we took some crazy network packet that was unusual and it loaded some Java class to handle it and went away. And the JIT knew this class existed, so he didn't bail out to the interpreter. He wrote code for that class. And then if you ever take this rare path, do this rare thing, fine. Okay, now you put this code in your code cache. The next time you start up, that rare packet doesn't happen for a while. The hot code's still hot. So you need to go JIT. But you've never loaded this class. Well, you can't JIT code for a class you've never loaded. So your code paths can't line up because you can't write the code for the class that's not loaded yet. Yeah. All right. So I think that's kind of a Java, I'm guessing it's a Java special problem, that not all language runtimes have to have this kind of an issue. Like if you're go ahead.
Was the thing where we reuse the profile, we actually do eager class loading, and we also have this mechanism of dependencies. Like some things, like we can try to initialize some classes early, but it's not always possible with non-trivial initializers. So we actually have this mechanism of we are waiting for the initialization to happen, and if we would trigger the compilations that are dependent on this initialization the moment the class is initialized.
Oh, interesting. Okay, so you are in fact tracking these classes that are not yet loaded under the theory that they'll probably get here, and then the jitted code is okay.
And the compilation will have the list of dependencies, like we need these classes loaded, we need these classes initialized. The moment you get this state, like, okay, I can
and then you must have some timeout that says it's not happening, just go ahead and jit.
Well, it's not a timeout, it's just if the method naturally reached the threshold for compilation, it will be compiled this way.
Gotcha. If you would normally compile it, you go ahead without the class and you just compile it anyhow. But if it hits the right metrics ahead of time before the compiler counts hit, then you go ahead and got it. Okay.
Yeah. How do you deal when the compiler tries to clone a function?
Clones it all the time. He inlines it. What do you mean?
So if I have a function and it's like, there's the string version and there's the int version, and I've just split it and got two native functions.
You don't have that in Java. Java has primitives and it has objects and subclasses of objects. So there's specialization, but that's always done by inlining.
So I'm never going to do a generic style. I made 2 copies of this and now I have 2 copies of every counter.
You do, but Arthur goes first. But it's not.
Yeah, I think in general, this idea of cloning and specialization is like one of the core things optimizing compilers do. Like you can, like basically any optimization, it's most of them are cloning and specialization. But in most cases, it happens within a function. Like you take a loop and you do unswitch, you created 2 copies within one function. Or like you do unrolling and also you specialize the copies. So this kind of specialization happens inside one compilation, but since we do this in our final tier compiler, we don't care about counters. We don't need to have like, we just don't care about this aspect. When like inlining is one of the examples of this cloning and specialization, and this can happen in our lower tier in C1. And in this case, we have what we call nested profiles. This is a context sensitive.
I wrote that code.
Yeah, it's still there, still works great. So that's how we get context sensitive profile. Like we can capture the profile for this method in the context of this call side, like for this specific specialization of it.
The original C2 heuristics here would look at the C1 profile of a method, and if C1 had further inline, C2 would be strongly encouraged to inline as well. So he would skip some of his threshold limits of saying don't. He would go ahead and inline matching C1's inlining pattern. And then he would just take the profiles, the nested profile counts from the C1 compile straight in as a nested profile count.
And if I wanted to save those counts from run to run, I just say, here's the tag, the count's tagged with context A, here's the counts tagged with context B.
Yeah. I mean,
do you have any idea how big a counts file would be? Like if I had a major Java application that's got thousands of classes in it, and I try to write out the counts file, is that like megs?
Or
is that like
kilobytes? It's megs. It's megabytes, yeah.
It wouldn't be, megs would be the right in-memory format. Like it's not the counts that are sizable, it's the metadata tags to understand what the count is counting that adds up. Even hand-rolled C code to hold all that shit. There's just so much of it. Here's the start of a C1 method. Here's its bytecode index and piles of tables of bytecodes with counts. And here's an inline point, and the inline point has another thing. And here's an entire clone of the tags and counts and yada, yada, yada. And it's 50 to 80%, I'm going to say tag data or metadata. and 20 to 40% actual count data. It's probably worse than that. Fine.
Yeah, so the profile is in megs. If we look at the cached code, if it's uncompressed, it can be small gigabytes, but it compresses well, so it goes into hundreds of megabytes. And one thing to note, it's not only native code, it's the LLVM IR, it's all the questions that compiler asks to the VM. So it has a lot of metadata other than just the native code.
It's not just x86 binary, it's a lot of metadata in the compile itself. Yes. It's not, profiles are one thing. The compile needs, here's all the classes I depend on, and every class has some subclass counts I depend on, and you can't add subclasses that override blah, blah, blah. And there's 50 varieties of such things, and of which some get big and some are small. Here I tried to compile this, assuming X would never happen, but it happened at least once, so don't do this heroic optimization again. And then it's all tag data and a Boolean,
So what's interesting, as I said earlier, as a key for this cache, we use the initial LLVM IR. We have a very simple parser. It doesn't do much in terms of optimizations. And we use this result. When we do cache lookup, we actually run the parser on the bytecode. And it generates all these, it decides, depending on the state of classes, whether it needs to bail into interpreter or do what the bytecode needs to do. But in the end, we just match this IR with the IR in the cache. Since generation of IR is relatively cheap compared to the rest of the pipeline for us, it's maybe 1-2%. It's still worthwhile to generate the IR for lookup in the cache.
I wonder if your generation of IR costs are similar to C2 generation of IR costs, and the rest of the C2 pipeline is a lot cheaper.
I think C2 does more things in that parser. At least it inlines there. Yeah,
it does the inlining, and it does people ops, which are fairly cheap. They're cheaper to do the people ops in the parser than to push the unpeopled code into the main optimizer.
Yeah, we have this thought that maybe we can. So we try to make our front end as simple as possible. Just for separation of concerns. But I think from compile time perspective, maybe it's a good idea to do these cleanups early.
Yeah, that was my experience. It just got rid of so much shit before you went into the main optimizer. He was going to get rid of it anyhow, but he was just, it was like a cache footprint thing I was theorizing. I would generate IR, immediately clean it up. It would fall by a factor of 3x or 4x in size, and then I would remake the IR in the same cache space, because I just had an arena with a bump pointer that would just bump backwards 4 steps forward, 3 back at every bytecode.
I mean, L1 cache is cheaper than main memory if you can clean that stuff out quickly.
Exactly. That was going on. Well, we beat this horse to death now. It's gotten quiet.
Next topic.
Yeah, next topic. Anyone? Here's the 5-minute AA update. Well, power out, no internet, both good and bad for coding and performance. Yeah. Oh, and leaks in the house, but not bad. And that was a lot of time spent. So I've gotten the test cases I have are all geared for the correct increase in complexity for the C-style flow typing, and the Hindley-Milner doesn't do side effects. So those tests come early in the flow because they're cheap and easy and they just flow through. And whereas all the fancy polymorphic function calls are late in the C code because I never got worked out because you need Hindley-Milner, and so they're late in my test suite, and Hindley-Milner is ready for them. But he has to do side effects because that's where the tests are set up now. So unless I reflow or refilter all my tests, at the moment, I'm just caught up to, and now it's time to do side effects in Hindley-Milner, which I know what I'm going to do, and I have a plan and whatever. So I can do the new fancy schmancy operator overloading works. That's all great. Simple functions that show up early in my testing all work great with Hindley-Milner. It's fine. All the error cases and all the above work great. And I'm up to my first side effect And Henry Milner's like, I'm so confused. And so I have to go back through it, actually add side effects to Henry Milner, which I know what I'm going to do there. And but it's just the next thing. That's where it's at. So progress, it's munching slowly.
So I tried pulling your AA repo. And the other day I asked about this and you said, oh, it's in a branch. I'm pulling everything. There's no branch. I don't know. It's not on GitHub.
It's been pushed repeatedly. It's called the branch. Oh, that's Discord. Here is GitHub. It's TV3 under prims 2 is the current branch.
Oh.
That is the one that is currently being wailed on. I haven't pushed it in a couple days because I had no internet for 48 hours and it's due for a push.
I wonder why Git is not fetching that for me. Weird. Okay.
Git is weird for me. I do not understand Git, but you found it then.
Yeah, I found it online. Yeah.
Yeah. It's there. Okay.
Yeah, because I would just occasionally do git fetch. Normally it fetched. I thought it fetched everything, but apparently something has changed.
Thought so too. Maybe it doesn't fetch branches until the first time that you bring a branch over or something. I don't run a ton of branches, so it's all not hard to fetch it all.
Yeah, I was able to fetch it just now.
Yeah, even if I do git branch -a, it only shows your master branch.
In theory,
okay, I'm just going to quote it again.
Go to test parse, and you pull up test 00. Let me make sure I spell it right. But there's only one test 00. Those tests and the tests in 01 all go. And then in test 2, I hit my first case of doing something that I don't like. Yeah, test parse 00. Probably test 01 run. Test 02 did not, and then I stopped and took a step back and said, I have to go reconnoiter. What am I doing? So somewhere in there, I went early and late bind issues. So this gets into a funny thing that I'm doing with AA that I could argue myself out of. So I'm trying to support something that looks like object-oriented coding as part of the standard AA life cycle, whatever, which in my head turns into you get a this pointer passed to a function for free under the hood, which in the way that I've set myself up turns into basically we can call it curried this pointer, and I curry it different points. So there's an early and a late version of currying, and bare integers that want to behave like a function curry late. You look at an integer in the typer, he's trying to type the expression, he says it's an integer, you did a function load, you did a field load from an integer, I go look that up in the integer class. That pulled me up, if it's an operator, it pulled me up an overload, I then do an overload field out of it, I got a function that takes the integer as the first argument. And then I curry it there. And bind that function to the first argument. So say 1 plus 2, eventually that sequence turns into look up an operator plus, look up the overload to go which of the plus versions you want, bind 1 as this argument to that plus function, and you're waiting to see the second argument to figure out which one, and you'll bind and call. Fine. If you're doing a normal field load and it's just a value, there's no binding going on. But if you do a normal field load and it has a function, if the function was declared in the scope of the struct, I'm assuming that you're making an instance method basically, and you get a free this pointer tucked in. And that means I have to do late binding, or all instances carry all functions all the time. So the function wants to move off to a class, but that means I don't bind it with the class header or the class object, I bind it with the instance. So I do the load on the instance, but the instance doesn't have this field. He then forwards it to the class, pulls the field out, binds it on the instance. That's a late bind. There's an early bind version where I just have a random stupid function I've made nowhere in the planet. It has nothing to do with nothing, and I've stored it in an instance. It's not a this pointer, but it happens to be in a field in an instance. Then when I pull it out, I have to early bind. It got bound going in, not when I pull it out. So anyhow, that bit of subtlety, it should make it look like if you write, methods inside of structs, they become instance methods sort of by default, but you can store random junk functions in fields and everyone will behave how you expect. So it should look just like...
Can I add a method to integer, or integer belongs to the language?
Yeah, eventually you'll be able to add a method. Yes, add a method to integer. That's totally a goal.
So could you take a function that's generated that's written in a struct, and then copy it into another struct, and it would what would the this pointer point to? And
point to the original struct.
Still point to the original struct.
It does with lexical scoping, just like you'd expect out of any statically typed lexical scoping language. Like we can pull up the docs and write stupid.
So to abuse the notation, a method is a lambda that closes over the struct it was defined in.
Yeah, I don't really have methods. Everywhere you put a lambda, it closes over its container. The this pointer is really the upwards exposed methods that you get. They are ambiguously the same. They're identical semantically. People want to call
define a function in a context, and then I attach it to a new object. It doesn't know about the object it's attached to, only the context in which it was defined.
Yes, you don't attach it to a method. Let me go. No. Let me go. So here's a struct. No, here is not a struct because Google wants to be confused.
We can share.
And it's Google Doc. Oh, I should share. Thank you. Boom. Share. So I have some struct here. I have some field X. I'm declaring a function in it like this. I have some field Y to make life a little different here. And here I say X is a function. That's a bad name here. So call this function. And it just does, X plus Y and returns that value. Okay, so in this struct, Y comes from the containing lexical scope, which is a struct, not a closure or a stack frame or whatever. And the this pointer is that struct. And then X was the argument that was passed into the function. So there is a case where
you will have to define it inline always inside the struct.
If it's lexically defined in scope. So let me show you another function, a little more exciting here.
So what about a function which adds a field to the struct that it's defined in?
So the fields are all pre-added. It's just a matter of when you did the initial set. So there'll be that field will exist. It will exist in the uninitialized or the nil state until you do a final assignment to fill it. At the time that you wrote the function, if it was lexically inside the struct, it is bound to that struct. And the implementation chooses to early or late bind for efficiency to get the method out of the struct and into the class. If the method was defined somewhere else, it is not related to that function anyway. You're just setting some function in. Yeah, somebody up here says, here's a function f. It returns a y, which is out of scope at the moment. And down inside, he says local f is equal to f. That is a function. That is a local field with a non-instance with function x. Function
F. So if I call local field on that object, I'm going to get a y not defined?
Right here. Yeah. Well, yes, because f doesn't define y. It has to be defined above the original one.
Okay. I guess I understood that there was a kind of magic this pointer that I could refer to, so I could say this dot y or something along those lines. You have to be lexically scoped correctly there, and this is merely a mental handle for you to understand that it behaves just like a Java this, but it's lexical scoping. It is identical to lexical scoping here. Let me finish out my little stupid example here. You can see what I'm talking about. So here's a function 2 that takes your choice of 1 or 2 locally bound functions, and one adds and one multiplies. Right? But those 2 functions are both locally bound. That makes
sense.
sense.
They have a hidden this pointer, which I'll use to go find y. You basically said this dot y without saying this dot. Whereas in the local f case, I will go add a different y. I want to call this z instead of y. So here is a z abc, a function returns the z. Local f takes f. The local f just takes some junk function that has no arguments and returns an ABC.
and doesn't care about cannot access the Y. Now, if you replace that Z in F is, blank arrow Z with blank arrow Y, that will be undefined because that Y is not in any scope, not lexically in any scope. So maybe that was the reason somebody wrote Y there. Oh, that's why Aaron did Y there. Yeah, you could put that back to make Aaron's error more obvious. I corrected the code to be not erroneous, but I think, Aaron, you wanted an error here.
Yeah, I was trying to push on the ambiguity of
let's
Y
fix
do
the
I
ambiguity.
get?
Okay. Y not bound in any scope. F is in error, right?
But we can just make that Y. And now it's this question of like, okay, I call func2, I get the Y that is this Y.
Yeah.
But when I call local func, I get Y.
You get whatever F's defined to be. Yeah, and it's completely out of your scope.
I think that makes sense because I think everyone is pretty familiar with lambda semantics and stuff, and I think it's I guess what I was wondering more about is when you start using this, and maybe there is no this available when you try and define F.
What would you do?
Maybe I'll write a little example. The example I would write is I'd have a struct and I define a function in it, and I would use this, and then I'd make another struct and I'd copy the function out of the first struct so it had a this. That makes sense?
I'm sorry, somebody broke the tab indentation, and so you have to say it again because I was staring at the code suddenly getting broken looking. Sorry, go again.
Okay. So I'll try and write this here. So have
same problem I had.
Thank you, Google.
All right,
You're being so helpful.
Yes, pick up soccer.
Yeah.
Got kids in soccer, eh?
That's right, eh?
Yeah.
Okay, so I'll say F is
and there's auto caps and start a line. I think I can turn off auto caps. Somewhere I found turn off fucking auto caps to start.
If you notice it, you can hit undo and it undoes the auto cap, but you have to notice.
Yeah, there was a way to have. I thought I was hopefully going to save a properties for all at time and place.
So can I do this?
There is no Y yet.
Well, what if I say, make a Y?
Yeah.
Okay.
Yeah. Okay. Picture.
You still
okay. Now you don't need the word this anymore. So this is redundant. You can get rid of it.
Okay.
Yeah.
Right. But you can use it, right? So if I use it.
It's implicit.
No, right. I don't have any syntax because I would just look up this, and there is no this. No keywords.
Okay.
Pretend there's syntax for this. I don't care.
No. Well, I thought that it existed. So okay. Anyway.
And F might as well be called a setter for Y. Right.
Yeah. So and let me.
I'll change the name to be Y setter. Yeah, struct1. That's fine.
All right. I'm just gonna embrace the capitals. So now I'll say, and now I say what I'm going to just have a Y setter here as well, equals. Okay, so this is kind of the idea.
Yeah, that'll set the Y in S1. Because S1 is not a type, it is an actual value. I mean, you've made it you've declared a variable S1, it's filled with a value, which is some particular instance of this anonymous struct, which has a Y and a Y setter.
Yeah.
You've asked for the anonymous struct S1 to go ahead and set its Y. It's unrelated to the S2's Y.
Yeah.
The confusion would come if you have inheritance, what this would actually mean.
So in the land of inheritance, if you declare if you declare a second Y, it's going to shadow the earlier Y, same as it would in C or Java. And if you write setters and you get shadowing, you're happy to shoot yourself in the foot, but you can do that. Like I haven't sorted out everything yet on how to do inheritance, but it's going to smell like Java's inheritance in this set. I mean, I'm going to be duck-like typing, so you can do more mix and match things than you can in Java. Oops, that's not me. Try again here. Find my cursor. There you go.
So if I did want to have an object, if I wanted to add a method to an object after that object was already defined.
You can't add a this guy after the struct's defined because you have to put it in the scope of the struct. If you want to assign a local variable or a field to some other function that is unrelated to being a local function, that's all good. Like the local f example, you could just overwrite local f with a different unrelated function, and that's all fine.
But you can come up with a syntax that after the fact, if you define a function that wants something to be treated like it was defined locally, you can have syntax for this. And it will treat the function as if it were defined inside the class.
You cannot, no, because you lose this pointer.
So one other question is, can I do so could I do a wrap function like this where I say I want to return self? Like I don't know how to express it.
Well,
so
S3
like
is self. S3 itself. You already have a name for self. It's S3.
Oh, right. Okay, that's right. So I can just do this.
Yeah.
Okay.
Oh, bye, Arthur. Changing S1's Y lexical scoping. Yeah, I'm not doing dynamic scoping, Matt. Yes, I'm doing lexical scoping. So on the guy who's doing the 0y, you need to have a field 0y set in the struct. You're making up a new field in S2.
So it's just going to tell me there is no this field.
But I can go, well, I can add the 0y field. So I can go, 0y.
Yeah, so start that set to nil.
Yeah, to nil, yes. Well, I got hit with somebody's comment colors. So then you say 0y is now assigned a function which, given an O, has to have a y field sets to 0. Then you pass it, and that function is outside the scope of S2, so it's
right. I'm trying to give it the scope of S2 back by wrapping it in a function.
Well, in your case, you just pass it as an argument. That argument goes right to the O. The O is now O.y is equal to 0. Sure, you just said O.y is equal to 0. I mean, you can write this code in Java, right? And you would get pretty much the same Java code plus a bunch of keywords and the exact same semantics.
Or I guess you could just have the lambda just directly say s2.y equals 0.
Yeah. I mean, there's no privacy here yet. Now we can throw privacy in, so that would prevent you hacking members of S2. But in public members, you can just go to town. So what were you trying to do with your wrap guy? What's the square brackets?
I guess I was trying to understand how to refer to the containing struct.
Ah, okay. And return the containing struct. Right now, you do it with a name. I don't have a syntax to give you the containing struct. It's likely to be just a dot as the syntax for containing struct. And you don't need these square brackets.
The square brackets, I meant to wrap it in an array.
Oh, yeah, then, yeah. So dot would be the self. That's my potential syntax, not yet sorted out. Right.
I see. And then if you did that, now the question is, can this lambda float free and be attached? Can I basically have a sort of mix-in function that I can throw in wherever I want, and it'll do the right thing?
Yeah, that's a. Oh, I see. That one is no, that one requires an S3. Requires an instance of this anonymous struct you've called S3. So all these cases, all these structs are anonymous, and you give them local names. If you were to have many of them, say you ran a loop and you built up an array of them, and then you're having one call another. So here we have S1, we have S2, which is making references to S1, and some code following S2 is referring to S2 or S1 or whatever. it's like in Java, you have many instances of these things if you run them in a loop, and you've got a lot of them.
Yeah, this reminds me a little bit of how JavaScript used to be done, where they ended up being a lot of functions that were used to create structure. So basically, people started emulating classes with various constructions of functions and maps.
Mm-hmm.
And then you ended up with sort of a constructor being a function that would sort of create the map and then attach all the functions that it needed to it with a sort of local.
I mean, that's my hash table example.
Yeah.
Where,
so you're thinking like of going sort of along that line.
Yeah, at the moment. And then there's a typing thing that comes along that more or less adds a lot of syntactic sugar. So here's a hash table that all it does is it's a no-arg function that returns a struct. And inside the struct, I have a hidden field, so a private field called table, which is an array of some initial size, and I don't tell you what its type is, and I don't care. And it has a put, and the put's going to take an element and do something to the table, or element and a value, key and a value, let's do key and value. And a get, which has a key, and it's going to return me a value out of the table. And whatever other things you put in a hash table, you know, clear it and give me the size and all those things. And, you know, the struct is just an anonymous struct that happens to have the right functions I want to operate on. So if I want to make a new hash table, and I say, you know, my hash number 1 is, you know, hash table of the function. Okay, now I have a new hash table. More or less said new hash table. And then maybe somewhere in here I said, you know, my hash dot put of Cliff and some Cliff person object. And, you know, I just did a put, and I can do a get, and all the obvious things happen there.
Yeah.
And I could make another hash.
But in this example, you wouldn't need the table to even be part of the struct, right? It could be sitting in the function itself.
I'm sorry, the table.
You will need to refer to it.
I have to share the table between get and put.
Yeah.
Yeah, but wouldn't it still be just as shared if it was sitting just above the @open?
Oh, I could probably do that.
Really?
Yeah, maybe. I still have to hand you back a set of. Yeah, I could do that. I can.
Now it becomes kind of private, right? So this is sort of the JavaScript way of making things private too.
Yeah, yeah. And you get back a struct with a set of methods on it. Yes, this would behave.
This behaves like a struct, but this is a function. When you call the function,
it's a no-arg function that returns a struct.
Doesn't this go out of scope?
No, because these functions, the put and the get, they have table and scope. They say, you know, gets this table of key, you know, mod, you know, 7, right? Actually say, you know, length table.
Okay.
And this doesn't handle overflow or reprogramming or anything. So here I have privacy, I don't care, right?
But because it's a function, when you call it,
when I call hash table with no arguments, I get back the return from hash table, which is the struct.
Oh, so here, if it's not private, you will be able to access the table.
No, I can't access the table because it's buried in the closure. So Derek's right. You can't get that table. It's private right now.
Yeah. How this manifests if this is a function?
Oh, I would have to have. So this is an upward exposed fun arg with side effects available in it. So I have to do an allocation for the stack frame for the hash table function.
So
but I'm doing an allocation for the struct anyhow. So I have 2 allocations in a row. Whatever. I have an allocation for table also. Okay. So the optimizer's job to run all those allocations together and be efficient about it.
So this is treated like anonymous.
Well, it becomes
outside. outside of the scope. Yeah.
It's out of scope outside of that. It's in scope inside. Yeah. Yeah.
Because that would be confusing. Not the people have to stare to think twice because
right.
I
And
think
I'm
people get used to these
JavaScript
patterns.
guys.
Like the JavaScript world used to do this all the time.
Yeah. And I'm thinking, I want to make sure the syntax, and it's strongly typed, and the syntax is reasonable for doing this. And for common patterns where you want to declare a class and give a name to it, I'm going to have some syntax to help with that. So we don't get 5 different versions of classes. But you could totally define a class in the language because...
Yeah, I was going to say, as long as you have class in the standard library and strong norms around your language of how to do it.
Yeah.
The thing that got JavaScript into trouble wasn't that there wasn't a good way to make classes. It was that there was too many good ways to make classes.
Right, and there wasn't a strong norm. So I want to provide a hook for strong normalization for that.
So in this case, this is a constructor for a hash table.
Yeah. That's right. Basically, where you just highlighted hash table, open close paren, I might as well have said new hash table.
Yeah, that's
right.
Yeah.
Okay. The other piece here, somebody has an add and bind functions. I'm not exposing bind because
that's what I'm saying is you don't have to expose bind.
I don't want to. Yeah,
I have created this function where I say I'm taking my S4 and I'm attaching an F to it, and my function is unpack whatever arguments came into the function and call the function, but with the object.
Yeah, but it won't.
Now there's this .o at the beginning that's got the object in it.
Yeah, right.
And my function takes in the .o.
Oh, I see.
And unpacks everything.
Yeah, and the only difference here is I don't have a way for you to reset the this pointer syntactically. You just have to use O instead of dot. Like you have to say, like in a normal struct code.
So my understanding was you were going to do structural unpacking, and one of the choices was essentially a using like thing that said just dump whatever was in O into my local namespace.
Oh, not okay. Unpacking of arguments happens at the argument level, not within the function. Like you have a new syntax which is currently highlighted, which I'm deciding what I would do with. The s4.f code, I'm just highlighting it. I don't know what color you get. Is just I have an anonymous function that's not related to S4. It takes an extra argument, which happens to be S4, and calls it with a tuple. F is adjacency is the only application is adjacency. F is adjacent to a tuple. Therefore, you have an application, you have a call site with a tuple. The tuple is unpacked. So S4 unpacks to O, and the arg ... unpacks to arg1, arg2, blah, blah, blah.
Right. So my instinct was to have this be a packing. Take all of my args.
Oh, I see.
I've got no args at the beginning of the args list, and I'm stuffing the rest of the args list into this tuple.
Okay, so you're making a var arg syntax.
Yeah, I mean, if I had an arg1, then it would be arg1 and stuff all the rest of the args into
I didn't understand ... was you actually intending AA syntax as opposed to you just saying, and I'm not bothering to write arg1, arg2, arg3. You actually mean var args here.
I was intending that this be the var args. I was proposing this as a var arg syntax.
Gotcha.
And stuff the rest into this tuple.
Right. And then
and once you have that var arg syntax, it is convenient to be able to say when I'm calling a function, here's the first argument, and unpack this tuple for the rest of the argument.
Okay, well, you unpacked oh, I see. Yes, if the tuple is of size 2 arguments, they would be unpacked to arg1 and arg2. If they mismatched, I would type you as a
right. If this has the wrong number of things in the tuple, then
it has to have a known number of things for me to unpack you to a known sized arg1, arg2 list.
Right.
Or else,
and the reason I want that is because it lets me write this function that says I am wrapping another function of some number of arguments that I don't understand.
Yeah.
And you gave me an appropriate number of arguments, and I call the next thing down the chain with one more.
I could do that piece. The next piece here where you've said paren is equal to O.
I was thinking this like C#'s using.
Okay, I don't have any way to set the this pointer intentionally. You don't get to set it. So the function for
F. So if I wanted to unpack Y from this thing, I would have had to be like Y. dot dot dot.
Well, then yes, and O would have to be a tuple, and you would unpack it O. So O is a struct that counts as a tuple, and then you would list the fields you're excited about. I see what you're trying to do there. So there's another version of the syntax using, again, dot dot dot, which says unpack them all in my local scope.
Yeah.
Yeah,
I might want to do a struct unpacking, because what I actually want is
struct
why.
assignment. That's actually not a bad syntax for unpacking.
And say, okay, if I want to unpack a struct, I unpack the struct. And I would require people to say dot 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 if they're allowing extra fields to be in the struct you didn't take.
No, so this syntax doesn't work because I don't have any way to talk, because it exports y out of the struct, but y has been declared only in the struct. I like this standard tuple syntax instead, because it's easier for me to say lexically the variables that appear inside the tuple have been exported out of the tuple and into the F scope. And I don't need the dot dot dot. I'm only going to export the named fields called O. No, I'll call them in order. So the normal tuple unpacking is in order only. So if O has a struct, those fields are unpacked in the order of the struct. Yeah, you can have a dot 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 rest, if I understand that's what's going on. And then
yeah, I'm saying tuple unpacking should be the exact same thing as var args.
I could probably go there. I'd have to sort on that some more, make sure there's no ambiguity. But yeah, there's something to be done there.
Because fundamentally what functions take when they take more than one argument is they're taking a tuple.
Yeah, and I've unpacked that tuple already. That's O, arg1, arg2. That's already been unpacked. And you're taking one of the args of the three and unpacking it again. Yeah. Exactly. And you're saying without using a function, unpack it. Well, okay. If I can unpack at a function, I ought to be able to unpack not in a function. And you know, like functions have a special magic trick they do. They unpack a tuple and name it. So I need to be able to unpack a tuple without using functions to unpack a tuple. Otherwise, you obnoxiously would just make a function that unpacks again in order to get the second round of unpacking, and you'd be annoyed.
But I don't think you need that syntax.
Yeah, right. I need the syntax to unpack, or else I force you to write a function in order to get another round of unpacking. Like you unpacked the tuple that contained S4 dot 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 args into O arg1 arg2. Now you're going to take O, whatever that is, and unpack it again. But if you do that with a function, you totally can do that.
Right. And my assumption is that O is just substruct.
And right. And now we have to have unpack semantics here, where I'm renaming the fields of O to Y and dot 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 rest. So the first field of O, whatever that field is now called Y. And is now available, Y is available in the rest of the body of F here. Y is available.
So is rest also available? Is it now a smaller tuple?
Is what? I could, yes.
It'll be everything but Y, yeah.
Yeah, I could peel off.
Yeah, because if that was just say drop it, that was a very verbose way
you could drop it as well.
No, if I drop it, I just drop it.
Yeah. And there's another
Well, if you're going to do that, then why all the crap? Why the ellipse? Why the parens, the comma? Why
because if I do that, then I error, you unpacked this tuple incorrectly. There's too many fields there.
Yeah, well, what's the semantics of tuple unpacking? Do I have to name every field, or can I simply let you unpack the one part you care about?
There's three things, and I try to unpack two of them.
Then I get you the first two.
There's different ways of doing that. In Clojure, it would just give you the first two, and it would be fine.
Yeah, I mean, I've seen people who also said it's an error. You have to unpack them all.
That's, I think, the more common.
I kind of either want syntax that explicitly says to ignore the extra stuff.
I'm okay with that.
Or I want syntax that says, no, do a perfect unpacking, and if there's extra stuff,
so when you call a function that has a return value, do you?
And I don't really care which one
capture it
has extra garbage.
I'm sorry, what, Mark?
So if you call a function that returns an int and you don't assign that to a variable, do you consider that an error? Like, it shouldn't be an error to discard things.
No,
right. So if you ask for one thing from a tuple of 4, you shouldn't have to say and ignore the rest. Like, who cares? The same way you can ignore the result of a function.
Right.
I think the dot 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 rest would be only if you want to capture a new subtuple.
Yeah. Okay. I'm hearing both arguments here. That seems reasonable. There is another piece to this puzzle, though, that also interacts here, and that's
do I want to claim that the capture field names have to match the field names that went into O if O was a struct? Suppose O is a struct. He has fields y setter, 0y. If you want to capture them, must you capture them with the same name?
Yeah. I think in my experience, it's really valuable to be able to capture what you care about and ignore everything else.
Okay, I'm hearing you, and I've used this in JavaScript before, and I'm also of the opinion that I want to be able to ignore the rest easily. And a easy ignore the rest is not even having syntax, you just ignored it. And now if it's a tuple, I can only grab in order because tuples have unnamed fields.
And well, I was going to ask you, how do you plan to do destructuring of structs or anything?
Well, just what people are writing here. Here's an example where f is called and assigns to a left-hand side, which is a tuple with value and error. That's destructing right there. Value and error now become in scope.
Can your structs only have symbols as keys? Could I make a struct where I say some string equals something because it's just a map anyway?
No, no. But because that hints at allowing dynamic lookup of fields by string. My structs are going to compile down to C-style struct objects slammed in memory using hard offsets for access, not turned into hash table lookups like JavaScript syntax, the JavaScript semantics say.
Yeah. Okay. Yeah, that was the question. So
yeah. So if I allow you to have something bizarre, I say bizarre, something odd like a string for a field name, I still will not let you do lookups on the string. You have to say, struct dot field name. If field name is quote ABC quote, I don't fucking care really. I'll look up quote ABC quote in the field names and say this is the field name. But that's that's too much.
Translate it to an offset, right?
Yeah.
Yeah. Why don't you prefix here the result and error prefix with something like struct, like value equals struct dot result. So you're not like the word result isn't all of a sudden, colliding with something else in your namespace.
I'm sorry. Okay, what you just wrote is value equals result. Where does result come from?
The question is, how do you rename stuff while you're doing a tuple unpacking? If I am unpacking a struct and I decide that I want to name my result value or value of result or
right. I could go there. What you just said was f returned me a struct. The struct implies a namespace. Inside the unpacking on the left-hand side, I get to use the namespace of the struct I got returned. I am building a whole new namespace, which will be immediately exported outside of the struct's boundaries. Like the whole point of tuple unpacking.
I was going to say inside the parentheses of a tuple unpacking action. Maybe you should have access to the names that are the struct that you are unpacking currently.
Yes.
And you should still need to qualify them with something, right?
No, there's nothing
result,
to qualify
but struct dot result. So what if I already have a variable called result in that scope? Which thing does it refer to?
Then it got shadowed. We have a namespace collision decision to make. I would claim that the inside the parens for the tuple unpacking, you got a new namespace, and that shadowed your prior result field. Furthermore, you can't put things in this unpacking except to unpack what you got from F. So you can't refer to things outside of what you got from F.
Right. I would say the left is the namespace that I'm in right now.
Okay, two
right
people talked at once. I heard neither one of you.
Sorry.
So yeah, Mark, go first.
So let's say I already have some struct outside and I want to assign one of its fields to be one of the fields that came out of F, right? Yes. So I do need to be able to do an assignment inside that temporary namespace you've constructed.
No, you need to unpack it. There are a couple ways to go here. If you only want the one field, you just reference directly. So somewhere in the universe,
no, but if I want to assign that into the field of another structure.
Right. Yeah. So I did this. I said F returned me a struct. I grabbed a Z field. I assign it to Y. If I want to grab multiple results out of F, I'm going to first grab multiple results and give them names. So I'm going to unpack what you've already got there, and then I'll say s2.y equals value because I've unpacked that already. But if you use the unpacking syntax, it explodes several names out into the namespace, but it is not an R value itself. Furthermore, inside that unpacking, you don't get to write arbitrary expressions because it's an unpacking syntax. There's a whole nother
well, it's more than just unpacking. It's introducing new variables. You can't reassign something.
Right. You're
unpacking.
That's fair. Yeah, and you're introducing unpacking and introducing new variables. It's as if I had a left-hand side new variable called value and a left-hand side new variable called error. Now, the colon equals versus equals tells me whether or not the new variables that get introduced, two new variables get introduced here, value and error, whether or not they have been finally assigned or mutably assigned.
Yeah.
So after this F here, here, value and error are in scope. Error is a mutable variable.
So if I'm tuple unpacking, I can't use the equal sign. It's simply that the order tells me which variables are being defined. And if I am struct unpacking, I must use the equal sign because the only way to get something out of the struct is to use its name.
Yes. Yes.
And okay, so next question is, can I recursively destructure? Because it's also quite useful.
I don't see any reason why not. I could totally do that.
Yeah,
so I don't have any of this implemented, but there's nothing that goes against the parser or anything that would make this hard.
Yeah.
So if where I have result, I instead put parenthesis.
You're recursively unpacking. Yeah, and all those names explode out into the namespace. I think that would be very useful as well. Having done my JavaScript time, I claim that would be a useful thing as well.
I mean, I can certainly see that pattern being used a lot for like a JSON thing. Here's my JSON parse. Here's my structure on the left-hand side.
Right. I'm interacting with somebody else's stupid JSON thing that I hate, but I've unpacked it and I need to go do something with just pieces, parts that are scattered about. First thing I do is I unpack it into local variables, however that's done. Yeah.
Yeah. And a common, I think, case is to have, you know, a positional thing where you've got, say, you're returning two things from a function. The second one is a map or a structure, and it's got some settings or like miscellaneous additional things. So you kind of want to grab the return value, grab the overall result, and then also grab some things from the contents of it.
Yeah.
And it's nice if you can do that all in one destructuring.
I probably could by doing this like that. Actually, it's probably the other way around. No, other way around. Hang on. Has to, in fact, be the other way around because what the hell? Google lost my cut and paste. Fine, this. So F is assigned.
But you might want to do it in the. So I'll write an example here.
Okay. I mean, I have it here. What you just said.
So in that line, F gets assigned to whole result. And then whole result gets unpacked into value, error, and rest.
No, but you're close. F also gets assigned into the tuple, which is the unpacking. I do not first cast it to result, then load result and throw it into the unpack. F's put into an invisible temp, if you will, put into result, and also put into the tuple unpack.
What are the ways in which that is not equivalent?
Oh, you're right. Never mind. I was thinking it was going to go, you're right. Okay, fine. Yeah, look. So, fine.
I guess, no, the difference is order. If I'm doing two unpackings and I'm going to throw an error because it doesn't unpack correctly, does the first variable get assigned before the you unpacked me incorrectly, or does the you unpacked me incorrectly get thrown before the assignment?
Static typing, no runtime unpack error. You got a compile time error. You can't unpack this. You returned from F. No, you didn't return from S a field called result. Therefore, I can't compile this code. It doesn't unpack. It's a compile time error.
And there's no I return from F field type dynamic. And we're going to do this unpacking at
That's
runtime.
correct. You dynamic things you write dynamic code for. This is all statically typed everything, right? This is static typing.
Okay, does this example make sense here that I just typed below?
I don't know what as means. So
well, so I didn't know, so I don't know what the syntax is, but I want to capture this whole struct.
So you return a data and an internal struct, and data maps to data, and you want to give a name for, well, this will go nested. Let me go write this in a different way. You want
to I want to grab the value out of X.
Yeah,
and I
I'm
also
getting there.
grab
I'm
the
getting
whole
there.
struct there. Yeah.
Does it matter that that's an array and not a tuple?
Well, he gives me, he knows he's telling me he's a pair. I put round parens around this as a tuple I'm returning.
Okay.
Round, right. Yeah. So right. So there you go. So you have an unpack on the left. The unpack expects two things. One's called data. One's called ops for all of it. Ops is further, unpack. I see that's not the right syntax yet. Where am I getting here? I
just want to have X as well.
Yeah, I understand. I'm trying to think of the right syntax that makes it semantically correct all the way down the line. Ops wants to be kind of, that's the first part, and want the name for it. It itself is the whole thing, and then I'm still sorting out how to do this here. There's another.
I was going to say, if you didn't want to name ops, I would certainly say you could unpack X equals X and just lose the Y.
Yeah, and right. there's another version of this that the problem is you're returning two top level things and you want three top level results.
Yeah.
Which oops, no, other way around. And I don't claim I like this one either.
Yeah, you could imagine that there's actually three things in the tuple, and maybe I want to ignore the rest. So I have an ellipsis in there.
Right. I mean, you're returning two and you want to give three names. And I have a breakdown pattern that works for, I could argue that the original one we wrote was probably the correct one. Ops is totally only given the top level, and then it has an assignment, which just means I'm going to continue the breakdown math. But then I don't have a way to only break down X. How about I only break down X? I want to say paren. I just do paren X. Why am I not? Oh, because the only way to do it only in the see the syntax for just getting out. So here's somebody wrote the one with I have two parts come out called data and ops. Somebody wrote the next line down. I have when data and the ops part, I'm only slicing down to just the X piece, which I care for. That also gives me two top level things, but I've further taken the right top level thing and broken it down. And I could say, comma Y equals 2. As soon as I do the full breakdown. So let's go do the full breakdown syntax and throw ops in.
Yeah, I kind of like the first proposed syntax now that I've looked at the two
I'm
that are
there.
already
I'm
valid.
coming around to it. Like here, Y is also exploded out. And if I do ops is like equal to a paren. Oh, that's it. Okay, so you say ops equals, it's the whole thing, and then the equals, it tells me I'm about to do another breakdown.
Scala would say this, and it bound.
I don't know. I don't want the @ sign there.
The Scala would say, and this would bind the whole structure.
Yeah, you're trying to. I'm binding ops to the whole thing, and then I want to say in the right-hand side expression, I'm going to take.
So you're destructing the structure, but you want the reference to the structure itself.
Yeah, because you don't want to put ops on the other side because you want to preserve the ability to refer to named things and
that's what.
No, well, inside an unpacking namespace, the rules. Oh, I can't refer to ops in the right-hand side versus ops in the left-hand side.
Scala in a pattern matching would say this, and this would mean I want to destruct the structure here, and but also reference to the structure itself.
Right. Yeah, that's what we're trying to argue our way forward.
Yeah,
I think we're
I'll show you the closure syntax for this if it helps.
yeah, and let's look at the JavaScript syntax for this as well.
Sure. So it would be, so when you're let binding, you basically grab a value and call f, and so that would be your normal binding x, but here we want to destructure, so we're going to do another vector, and we would say data and opts, so that's the top level structuring. But then here I can say keys.
No, okay.
So this is closure, and then I could say x, and then close, and then, well, I don't need that.
Well, how do you get y? You want x and y and opt.
As opts.
Oh, and that's the as word.
So then this maintains that it's key value pairs. It's like keys.
Okay.
And then we have the key destructors, and then as means we're grabbing the whole thing. They also have some other stuff that people don't use much, like defaults. So it'll actually default these values, but that's I don't think it works very well. Nobody uses it.
Yeah, another way to view this problem is to say that I want all the parts, I want y as well, and I have 3 total parts that f's returning, and I want 4 total names. As soon as I want 4 names from 3 parts, I have to have some funny non-matching syntax because I've had extra names over the parts. I can't just do a breakdown, a structural recursive breakdown that matches line for line. Yeah, that one gives me ops and data, but not x and y. And the second one down gives me x and data, but not ops.
Yeah. So doing the top one, you can always do the x thing as another line. So it's, at least it's got the flexibility, but
yeah, I mean, I could just, right. I mean, if I just do ops on the next line down, I can break out x and y, but I hear you, it'd be nice if they went, like the syntax that the anonymous ROX is currently on is not, I believe, ambiguous, because I don't put an equal sign on the left-hand side, except to work into the portions. That's right. Except to use names directly in the namespace that are theirs. So ops is equal to a tuple, which is the whole thing.
Yeah.
All the fields of x and y, and then buried inside that tuple, I can break out an x or y or either or both. So actually, the third one down is currently, I think, unambiguous, including the dot, 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 or not. If it's a tuple, I don't need a, oh, it's a struct. I need a dot, dot, dot. Yeah.
You know what I think might make it more unambiguous is if you put the opts equal and then the destructure in parentheses, that whole statement in parentheses.
Well, write the line, because we have too much going on here. Yeah. Whoever did 1, 2, 3, 4, 5, there is a naming built into the Google Docs, but I don't claim it's what you want.
Yeah. So I think I want. I don't know.
Yeah, I would say 3 should make ops a tuple containing only x and y. Yeah. But 4 should make ops a tuple containing whatever was returned.
Yes.
X, Y, and potentially more.
Yes. The 3 makes ops a tuple where you've dropped some values, potentially. You demand a Y and you drop everything else. And 4 says, I know I have an X and it's named X, and it's the same tuple as what got returned. It has all the fields. I think that's correct difference between 3 and 4.
5 I just don't like very much.
And 5 I don't like either. That's one where all my names are at the top level. So I can walk down the line and assign names, but I don't like 5. 5 is just another way to put x.ops on the next line down and just save a line, which, I don't like 5.
I think 5 would be very confusing, especially if the tuple had another thing in it.
Oh, we should keep adding things. Yeah, sure.
Right, because imagine the tuple has 3 things in it and you want to ignore the last one, and now you've spawned this additional statement in the destructure, and now it's ambiguous which thing it refers to.
It could be. All right.
Hey,
I'm
Cliff, what does
agreeing
X equals X mean in the like 3
okay,
and 4?
that X on the left-hand side, X is I'm putting a name that's in the namespace that follows the entire statement. The right-hand side X is in the namespace of the nested tuple that F returned. So this is a left-hand side destructuring, and the names that are in that namespace, the new names on the left-hand side of any assignment or just standing alone are all new names in the current lexical scope. And the right-hand side is restricted to names that appear in the return value from F.
Okay, so is there, can I just say X? When it's the same name in both?
Well, okay, so if you're returning a struct, it would be the same name X, you're correct, and the syntax probably should be a little different. Like we could argue that I should use curlies because there's a renaming choice and there is just use the field directly. So you're suggesting that this says it's the same as X equals X, where the X is used once on the right-hand side namespace from F return and imports the X in the left-hand side.
Yeah.
It uses the order to implicitly rename what you want.
Well, and then because F is returning me a struct, and I know that, it's not order, it's names. And so because it's returning me a struct, I could argue that you actually should have the struct syntax here, like that.
Yeah. So that's kind of look at like you put a name to the anonymous struct here.
Yeah, it looks, because it's a left-hand side unpacking, your names get, overall, it gets confusing or easy to misread that you're doing a complicated left-hand side unpacking, and it begins to look like I'm doing a big assignment of a big complicated structure, but it's still an unpacking only syntax.
That looks fine to me.
Okay, I'm eyeballing the confusion here. Having tuple syntax for unpacking is common in many languages. Having struct unpacking is common, but usually you use round parens for struct unpacking. And I'm pointing out that I can tell the difference between tuples and structs, so I can demand tuple unpacking syntax and struct unpacking syntax separately and independently.
Scala has a case class destruction. It uses a name, and you use the same pattern as a tuple.
Always you're using a tuple pattern to do the unpacking, which is fine. I'm asking a question. What is the weirdness budget here for choosing to only ever unpack with parens? There's a consistency, the goblin of little minds is too much consistency. There's a consistency pattern here that says, I'm unpacking structs via a struct-like unpack syntax. And I don't claim one is better or worse than the other. I can easily see one is little weirdness. Like, we're unpacking a tuple from F, but F could return me a struct, which I'm also unpacking. And now it looks like I'm defining a new struct on the left-hand side as a whole thing instead of defining a bunch of fields that are exposed.
Yeah, Scala can convert case classes to tuples interchangeably because it treats them sort of like the same in the pattern metric.
Item line 6G returns. I'm going to argue
so here's another one, but we have a new function. It returns a slightly different data structure. And I'm saying using the same return type as number 6 above there.
You need curlies around structs because curlies define a lexical scope. Whether it's function or struct, they define a namespace.
We shouldn't go overboard with this. You should support the most convenient patterns because...
wait, we should always go overboard and then back off.
Okay.
You should try too much, too hard and say, wait, but this is the exploration.
Here it starts to look cryptic.
Right? Yeah, and here I'm going to claim you would put curlies here because you are returning a curly structure. You're renaming A to data. You're producing back a tuple B, which wants to be the B that comes from the other right-hand side. Yeah. Which you will, because you've not changed the name, I see, you want to have the option to change the name here. This would be if you want to make this obnoxious, you rename B here. And now I have this.
Yeah, that would be better.
Right. Sure. And then, here, this is another tuple. where I get a full name for the rename of all of the B, and also I break down B's internal structure. And I'd use X for X, which I can, as pointed out by Bill Verners, I can just get rid of the extra equals X.
Yeah.
There's somebody did a JavaScript version. That looks good. Do a nested JavaScript.
I was just saying that
version
dropping X equals X is a thing that JavaScript does when you're doing unpacking. You can just say A, not A is equal to A.
Yeah, I think that's a good shortcut, because it's the common case. I want them to be the same. I don't rename them because my life gets confusing anyhow, and too many renaming of A to A is like, what the hell? Or in your case, data becomes A becomes data. In Derek's case, you did data to A to data.
So my problem with not doing the rename is I don't know whether I just pulled this thing out mutably or immutably, because that's a thing I learned from the assignment statement.
Oh, I would by default always claim your. Yeah, good point. I'll claim.
I mean, we could say X simply means X equals X, and if what you meant was X colon equals X,
yeah,
then
I think you have to put colon in. I think immutable by default. You can put colon equals if you want a mutable version.
Yeah, it will make a new version of X, which is mutable, not the structure.
Since they're right, you're making a new X. It's mutable. So, all right, since you can always get at a syntax,
that's kind of cool. That's kind of cool, and it's tricky at the same time.
Yeah, the nested destructors are a little tricky, but they are useful.
I'm there. I've done it.
I do kind of, it's kind of funny to me to have that at curly being the destructor, because I would think that when you're parsing this, you're like going along thinking you're building a struct, and then you get to the end and you realize, oh, there's an equal sign. It's not a destruct, it's a destruct.
Well, right. And the parser doesn't terribly care, but the human eyeball reading it does. And now we have a question of what is the correct syntax for destruct. And that gets right back to, only ever use parens, because people assume that's destruct, whereas the at curly thing turns into, I'm defining a new anonymous struct.
I would say
parens could be building a tuple. It might be interesting to say in this language, always build tuples with square brackets if we want round brace. If we want the round to always mean destructure, maybe square should mean tuple.
Well, I'm coming around. Okay, so for Derek's issue here, I'm going to claim if you start with an open curly, you've started a struct definition. Because it's an anonymous struct against the left-hand edge of your code, you didn't assign it to anything, it's dead. So it must be a destructuring syntax instead. If I say A equals @ struct, I'm now thinking I'm assigning A to being some big hash. If I say my hash is equal to some complicated struct, it looks like I'm making a new struct. And that's an eyeball reading jar. Whereas if I just put it as a destruct on the left-hand edge, I claim it's not really, you should be able to tell as your eyeball the first thing. Oh, I have the start of a struct syntax on the left-hand side of my code. It's a destructuring syntax. Whereas if I'm doing what whoever's typing in there now, name equals blah, blah, blah equals G. Now this looks like it's not destructuring syntax. And that actually might be ambiguous. I might not be able to tell it apart. And that might just be an error. I might have to claim destructuring has to be up against the left-hand side. You can't do name equals. Like earlier, Aaron, we had said whole result is equal to tuple of value result, blah, blah, blah equals F. I could argue that that's ambiguous. And I want to claim if you want whole result, it has to be on the other side. And
you're doing that right in this statement we're looking at in rename _B there as well. You're doing exactly the same thing.
Yeah, it is. That is correct. Okay, so let me go restructure this entire line to be a syntax which maybe is less ambiguous.
But I think parens do destructuring and @ brace doesn't do destructuring, is less ambiguous.
Do you have anything that you're using at open paren rather than at open curly?
No. What I really wanted was namespaces are introduced by curlies, and they need a way to tell structs from code. So that's the @ sign. Now that I've got namespaces are always by structs, unpacking is weird because that's not a namespace. That's exporting into the outer namespace. So curly is weird there as well.
Yeah, maybe you need like a tilde curly or something for this.
Well, or not use curlies. I could go to rounds everywhere as well, and then I know from typing time that I'm getting back a struct or a tuple. Right, from the typer doesn't care. Tuples, in fact, have names for fields called .0, .1, .2.
What is the syntactic meaning of your @ sign? Like, I get it that @ curly is
that's the only
creating a structure, but is that it's only just @ curly?
Yeah,
the @ sign itself doesn't have syntactic meaning, because you're saying that curly is a scope.
Bare curly is a start of a function. @ curly is the start of a struct.
Yeah.
How do you start lists or arrays?
And arrays will be square.
And are you going to have any sort of map syntax?
Not yet, except that square brackets can be overridden to behave like maps. So yes, there'll be map syntax in practice. It'll just be an operator overload. All the square bracket things are operators. So you just operator overload them to be map-like syntax.
I would say just use the parent syntax to enforce more uniform access, be it a tuple, abstract. Because
I'm headed for curlies for tuple unpacking because it's not really introducing a namespace.
Oh, okay.
It's making new names in the current namespace. It does not introduce a nested namespace. So what I wrote for the second 6, which I'm going to rename to 7, I think is a syntax I'm happier with. There's a whole name option for each individual nested parts. It has to be on the left-hand side of the start of a statement. Like the usual way you do an assignment, it's only a statement. The statement has variable equals blah, 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 blah. That's an assignment. It only starts at a statement. This is another version of an assignment. And therefore it must be on the left-hand side of the start of a statement. And therefore you can't do it embedded in the middle. Or I think you can. Well, you can but it becomes hard to read because you have to keep reading until you find the equals to know that I'm doing unpacking or not. So I claim I'm going to force, right now I'm forcing this in my head. The correct answer is to force tuple unpacking to only appear on the left-hand side of a statement.
Yeah, the thing you get back to is if you look at number 6 above, where the second argument is it's where you're destructuring a tuple, not a map, and then if you switch the opts and the x equals x around, then it starts looking like a map destructuring again, a structure destructuring again.
I'm looking at like
number 6 above, right?
Yeah, I'm looking at number 4 instead of number 6 is where I want to head to, but they're very similar. Yeah, sure. They're basically the same. Yeah, okay.
They're almost the same, yeah.
Yeah.
I just put an extra paren around them.
And
you need the paren. It's not extra. I see no. I do see an extra paren. I would kill on 6 the extra paren. Why?
Yeah, so that was the whole point of that line, to put that extra paren.
I would claim I don't like that because in theory, right now, the semantic meaning of a destructure is if you're in this list inside of parens, you're at that level. And if you go another parens in, you delve into another level of tupleness from F.
Oh, yeah, that makes sense. Yeah.
So I claim no on 6.
Yeah, that makes sense.
Because
then
when you do the 6 with the extra pair of parentheses, you've just put the X from the next tuple into ops, and you're now trying to unpack X.
The parens around the ops equals says that F returned me a tuple, and it has an ops part in it, or it has to be a struct that has something that has an ops thing, has a part that I can find for ops, and then furthermore, I'm going in again
Yeah, which isn't what I meant. So obviously it's no good.
Right. So it has, right. It's either ambiguous or it's confusing. So we just leave the
Okay, so
parentheses.
I'm going to get rid of this one.
Yeah, but that goes right back to what 4 is. That's just what 4 is.
So, but then, yeah, so, but I'm going to change it here. So,
Okay. Yeah.
So you were saying that you want to switch this around. So let me just say X and then equals alt.
Yeah, no, there has to be something on the right-hand side of equals ops to what, if you're going to rename it. If it's just a part from a tuple, the syntax is different than an array, than a struct.
Yeah.
So this is a confusion that I'm willing to, discuss as well.
What are the rules in renaming a variable in a struct and binding a completely new variable?
The tuple binding thing is binding a new name. And in the case of returning an F tuple, you have to go in order, and returning an F struct, you have to go by name. So far, that's my, high level design goal.
Yeah.
I don't know.
What I wanted to point out with number 6 here is that in number 7, you flipped the order of the rename B, you put it after the destructure.
Yeah, and I can be argued
the name after, so you have equals name equals G parent.
Yeah, I'm right. So look at
what I'm saying here is in number 6, if you look at that same convention in the context of tuple destructuring, it ends up looking a bit ambiguous because it looks the same as
I'm there. Here's my issue I have with 7, where you put name equals in the front. To my eye, reading it, it looks like name equals a tuple, blah, 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 but not a destructuring. So I want to make the fact that you're doing a large, complicated destructuring obvious from the first few characters for the benefit of the reader. The parser doesn't care. The parser can deal either way cheaply. So here's a new syntax. You say, add a new character in the language.
Yeah.
Demand, this is a tuple unpack.
Yeah.
Right. I would probably use % myself, but fine.
Okay. Well.
But you're gonna grab a new right, and now put the variables back in the reasonable order, which is rename B is equal to unpack the parts. Name is equal to an unpack. Oops. Some weird scrolling thing happened on me. I'm going to scroll again.
%, because you're dividing up the struct and leaving remainders behind.
Or maybe, and then
I have a high level aesthetic that I think might be a good guide for any language, really. And that is that, construction and deconstruction are duals to each other. They're the same thing in reverse. Or packing and unpacking. And so like in Scala, for example, list A comma B comma C, it depends on if it's like between case and rocket, or in your case, tilde or %, right? It depends on it's being part of a pattern or part of an expression. If it's part of an expression, A, B, and C have to be defined already. And then you insert them and then you get one thing out. If it's in between case and rocket, then A, B, and C are brand new things that pop out, but one thing goes in and 3 things come out. But they look the same. So as long as the person, and I think that is simpler. Like if it always looks the same, Scala doesn't get there 100%. But most of the times, the expression looks like the pattern. And you can tell if it's deconstructing because there's a case word there, even though that's verbose. It like people don't get confused whether it's a pattern or an expression. And I think it's simpler when it looks the same. It's going in reverse.
What I heard you say was, if I add syntax to tell that I'm starting a destructuring, then I don't care where it happens, when and what order things are destructured, because the syntax tells me immediately, I can tell.
Well, can you take it out and put it in an expression position and then evaluate it if those variables are defined already? So the equal sign, I think, makes sense. Like Scala uses an @ sign that you can't, like if the pattern uses an @ sign, you take it out of that pattern and put it in an expression, it doesn't work. What works is an equal sign. Equals is a named parameter. So I think equals is actually something that's goes in, is a nice symbol for that.
if the struct is on the left-hand side, you're defining all the variables. If the struct is on the right-hand side, you're using all those variables to construct the object.
And it looks exactly the same. So any way I can deconstruct, I can take it out, put it on the other side. And if those variables are already defined, it will actually evaluate and get that thing.
Yeah, I do like the idea of the left-hand side syntax being identical to the right-hand side syntax.
Okay, under that model, to tell what I'm destructing versus assigning into or building a new struct, I have to make it all the way through the struct declaration and find an equal sign in the right-hand side. Or
I have to know, am I on the right or left-hand side?
I have to go a mile. I have to go to a mile to the right-hand side to find that I'm not assigning a variable. I'm in fact deconstructing. That's the issue I have here. The line 7 is destructing, but I can't tell. If I get rid of the percents as a keyword token, I can't tell I'm destructing until I get to the equals G. If it was a big destructure, that's a long ways.
That's why the Scala has the case word in order to denote.
Put syntax in, it's okay.
Kind of boilerplatey, but I think it's useful for that reason.
But I think the percent sign is basically doing the job of the case word.
Yeah, it's doing the job of the case word, right? But what my point here is that it's not the same syntax left and right, because one has percents or cases and the other does not. If I grab the parts that are in that are not part of the percents, like the percents are even nested in here, so I can't just grab and cut and paste. If I had a magical, this entire thing is being destructed syntax, and then it matched assignment or creation versus whatever, maybe that's okay. And there's an 8. I'll do an 8 here that does this thing where I use name is equal to percent. I'm going to just use percent once to say this is a destructuring. Data equals A, and now I have to do a destructuring without any more percents. So I have the problem that I had before about rename B equals ambiguous. But maybe I don't care because I know I'm destructing. So
well, the only time you're going to end up with an additional percent sign in the middle is if you're trying to define more things.
Well, I'm trying hard to, and the X is a...
So like in the same way that we defined ops and then we destructured ops right there, you would end up with another percent sign that says, hey, I've stopped doing this destructuring for a second because I need to structure this piece of the destructuring.
What I'm trying to do here is to say, can I make it so that I don't need to have the percent in the middle, so I can literally cut and paste the code? So on line 8, I have one token that says, case token, percent says, it's a destructuring. If I get rid of that, I instead have valid syntax for creating a new object, not destructuring. And is that easier to read than line 7, where I've got parens for tuple destructuring? And by the same token, if I'm just returning a value and an error from F, so the same syntax here for this guy, value, comma, error, equals F as a function, has to have this percent in the front. In the simple case where I don't care, there's a simple case where it's obvious and it's easy to read. There's a complicated case. The complicated case wants something to help it without necessarily harming the simple case.
Below, I added some Scala examples, which are always the same.
Val is another one. Between val and equals is a pattern. Between case and rocket is a pattern.
I don't know what case and rocket are.
Case, like if you have a match or a catch in Scala, then you say case, 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 and then you have a case space pattern.
Okay.
Like CKPC, and then equals greater than I call rocket. It's just like a right arrow, fat arrow. And that's the pattern. Those are like the left and right sides of the pattern. And so I'm between those, and it's not an expression, it's a pattern. It's going the opposite direction.
Okay. So rocket is a short for equals greater, which
equals greater. It's a
it's fine for rocket. Okay.
Or whatever, but there's too many arrows. So
yeah, right. I only have one arrow right now.
Different names, but
yeah, fine. So anyway. Do people like 8 better than 7?
That sign is like val in Scala. It's a keyword. I know you're trying to avoid keywords, but it is a keyword. It's just
it is a keyword. Yeah. It's a keyword.
So I think it's important to have that something. So
it's
I know
not val either.
Whatever.
I don't have a keyword for val.
Right. I'm saying that it's good, important, I think, to show at the beginning this is a pattern, not an expression, or this is a
the at sign is a struct. or a class. It's not a val keyword. I have no val keyword equivalent.
Yeah.
So the idea here is that if on either a parenthesis or an at brace, you prefix it with the % that you are a destructure until you hit the balancing object.
Yes, that would be
even if there's nested destructuring.
That's correct.
So here the % is the case like Scala. It's a symbol to denote that the structuring starts.
So if you have a composite structure like that on the left-hand side, how often is it that you don't want destructuring? Like, what do the cases look like where you're actually building up a structure, but you're starting at the beginning of the line? Does that make sense? Like, if you're just building a structure, what are you going to do with it other than destructure?
Oh, well, usually I'm returning a structure like a person object.
Yeah, but you wouldn't start that line with the structure. You would start that with the, I think you use the caret syntax for return. Is that right?
I'm sorry, if I'm returning a complicated structure?
Yeah, if you're returning a structure, what's the syntax to say, I'm returning this, right? Do you just declare the structure, or do you have to say return with the caret?
No, the last expression of a function is what is returned. The caret gets you have an early return. So you would normally use the up caret in a branch of an if to say I'm doing an early return.
It's the same thing on the left side or the right side. What would it mean to have this piece on the right side of an equal sign?
Are you the guy doing the?
I'm highlighting the.
I'm doing the functions.
Oh, you're in the functions.
X.
Yeah, the functions I was looking at. Wait, sorry, say again, Aaron. I'm now looking at the correct code.
On line 8.
Yeah.
If I were to have that on the right-hand side of an equal sign.
Okay, so that has already got another equals. That would say B's in scope and is being assigned to a thing. It would be an error because I don't have a destructuring. I can't take that sub expression out and put it without a destructuring tuple marker.
This and this are equal in this.
Okay, so I can't in the middle of a thing going on the right-hand side of an equal sign say, I'm doing an assignment, but let me do some destructuring in the middle.
Right. Yeah. Right. And if you look at the 7 case, you could, because he has that % there.
Yes. In the 7 case, that would mean I'm doing some destructuring in the middle of my defining.
Yeah. You're busily doing a destructuring of a 2-element tuple, and in the middle of doing that destructuring, you discover you want to destructure it again, and each time you begin destructuring, you need another %.
Which I don't necessarily think I want to disallow, but I probably do want to have a lint warning for.
Well,
to be like, hey, you're assigning a thing in a weird place.
That's not an assignment. That's a destructuring.
So what would be equal B here? What would be
in this context? This grabs the B field from the top. You don't have a B here. Why is there?
Yeah, we do.
Yeah, we do. Oh, we do. It's G. This name thing. Yeah, he grabs the B named field from the G's initial value. The G returns initial value.
But by definition, you rename B and destructure B. This means you destructure this structure here.
That's correct.
You make the X mutable and you are equal B again.
No, the new value is renamed B.
No, the whole thing, the whole thing is renamed. B is renamed to rename B.
Okay, B, okay.
And the destructuring is its own separate thing, and he changes namespaces. That X becomes the destructuring of what B was. And the new X is always going to be exported to the top level. That's the whole point of a destructuring. It gets exported outside of the entire line 7.
Okay, so to use it, that's fine. And
I'm still waffling around of demanding destructuring be on the left-hand side only, which means that, you have to move the whole value name equals over to the right, but that looks weirder in other contexts. So, it's a little weird there, or we're a little weird here.
This makes sense to me because of the example 6 above, which I think is confusing.
Yeah.
Because it looks like a named destructure.
Yeah.
So if you have opts on the left of the x equals x, then you're kind of safe from that confusion.
Yeah. I'm with you. I like them on the left, but they do then, in the complicated case, they do then want some kind of percent to say, this is a start of restructuring. And for me, the consistency says you have nested percents, and then you don't cut and paste destructuring syntax as creation syntax elsewhere. That's not a design goal of the language, if you will.
Yeah.
The B equals mimic here the rename equals. It mimic the definition with the renaming.
It mimics, but it's not, because unpacking doesn't put rename in the scope of the nested parens. It puts the rename outside of statement 7.
To use it here, okay?
It's as if you put rename there. That's correct. That's correct. And that's the whole point of destructuring, but it is also the reason why the syntax shouldn't, in my head, shouldn't necessarily match construction. Fundamentally, they're doing different things. One exports the namespace outside of the expression, the other does not.
But, okay.
Okay, so if we pull all this back to the example we talked about months ago of the way that you do import statements is import is a function that returns a struct. And if you want things out of the import, you do that with destructuring.
Right. Then it would be a destructuring. So there's some way yet.
I now need to start every single import statement with percent parenthesis.
If I'm doing Java, I do import.
I guess that's only if I want to use destructuring. If I want to import something as a single symbol into my namespace, it's still just name equals sys.import, whatever I'm importing.
That would count for destruction.
Yeah.
And if I want to import A, B, and C.
Right. I'm importing math, but I only want square root, not the entire universe of math dot. So I want to say square root equals sys.import math, except I don't want to say, parens or whatever. What are my syntax for importing? My syntax is for tuple expansion, just get square root out. So somewhere, well, who knows where my cursor is? I'm lost in everyone else's cursor too. Let me throw a square root below 8 here, where I say I want a square root. I want it to be an unpack square root. I don't care for the rest. Sys.math. And maybe it's sys.import. I haven't got import syntax worked out yet either. So, pardon the ugly. And that just says import math. That's probably not what I want to do for imports. But I get back a giant struct with a huge namespace. There's a square root field. I export it. Now I can say square root equals blah, blah, blah. And I get use math in a sentence, or use square root in a sentence.
We must agree on the syntax because 2 people type the exact same thing at the same time.
People are still screwing around. Oh, I see. Yeah, there you go. Yeah.
So it seems like the percent thing, it makes sense to me. Like, I kind of like it. It works. It seems sensible to me in the context of function arguments. I would assume you'd want to be able to destructure them too.
Function arguments get a free destructure syntax already, so I don't need the percent and the parens around them. I'm just going to destructure them as if you did percent parens. That's a syntax.
But what if the first argument itself is a tuple? Wouldn't you need the paren?
It's only ambiguous if you want to pass one tuple. So in the in my opinion, relatively rare case where you're passing exactly one tuple, like if you pass, right, okay, exactly one, then I'll have a special syntax that says, don't unpack me instead. And it will probably have tuple parens involved.
Okay.
Or
this
just
is kind of like racket, isn't it?
Rest. Yeah, Aaron, yeah. I take one
this
argument.
Is like very scheme or rackety because it has this concept that functions you can either look at the arguments as the one tuple, or you can destructure it.
Yeah. I am headed to that kind of a path. Yeah. There's semantically always a tuple. The JIT will take care of the tuple for you. You'll never pay for the tuple.
Yeah.
And then semantically, it's as if you got a tuple that was unpacked. If you don't want to unpack it, call for the tuple directly, and you'll get it not unpacked.
Right. So then this first example, you can just get rid of that stuff.
Yeah. Right. And
then the second
I don't
example,
need the comma either, because I already know I'm unpacking a tuple and I have a special syntax. So just a comma. It's just that. Yeah.
And then what about the second example?
So this example says I want to break out the parts. I don't know. One claim is I've begun destructuring on the left-hand side of a function, and I should begin as if I've already done the percent and know that I'm destructuring immediately.
Yeah, I feel like the fact that you're in an arguments list.
Yeah, and now I'm only past the tuple, so you can't use data equals A. You have to use positional. So get rid of equals A. I'll get rid of equals A. You get rid of equals A. Yeah, get rid of equals A because you're in a tuple.
If I call a function with
the
a
first
single
argument could be a structure, right?
Yeah. You're passing a one arg function, a tuple, I mean a struct. The structs has some fields. Fields.
Yeah.
Right, but if I'm passing in one argument and that one argument is a struct, it's going to get wrapped in a tuple, and I'm going to get past
a struct.
Yeah. So,
like that was our rule, was functions take tuples.
Yeah, and then the tuple gets unpacked. You didn't ask for the don't unpack me, so you got unpacked. So you got your one struct. Now you have more unpacking on the struct. And I guess you could say, yeah, you could put that back to the equals A and stuff. Yeah, okay, that would work. Let me see if I can undo my own hacks here. And that would mean
I guess the thing I'm barking up is I have found named parameters functions.
Yeah.
Named arguments. I have found a useful feature.
Yeah, there are named parameters on functions, and none of this syntax is there. And now, is there a uniform way to merge unpacking and named parameters?
So if I, at the struct definition site, start doing unpacking, is that a way to signal that this is a function that takes named parameters and not a function that takes positional parameters?
Again, I'd have to go sort on whether it's ambiguous. Maybe.
No, it means you don't get the Python style mixture of I have two unnamed parameters and then three named parameters. You have to say, but no. This function either takes a tuple or takes a struct. Either the parameters are named or they're not.
Well, here's another way of thinking about this, that you can, just like in this one, you are sort of one step into destructuring when in here. So you could also be one for named arguments. You could be one step into the destructuring as well, and just basically get rid of that. And now there's your named arguments.
And if I pass a struct with fields called A and B, they were the named arguments, and then I renamed them to data and renamed B or something.
Kind of like you have a free tuple, but here instead of a tuple, you've got a struct. I don't know. That's kind of the thinking, my thinking. And then here you've got a tuple with one struct in it.
Wait, yeah, okay. So let me have you named arguments, but like done in style. Because you gotta do.
I kind of like that for named arguments, that you not only drop the percent, you drop the entire percent at open brace and the close brace at the end.
Okay, so here I have 18 named arguments. I'm just like dying in named arguments. Now I want to call this thing. I want to say FS. I'm going arg0, arg1, arg2, arg17. Okay, wow, what a pain in the neck. Can I name the argument? So there's two goals for naming arguments. One is pass the default and skip half the names. And the other one is I've got 17 Booleans in a row. I want to call them mode X is fast, is last gen, is this, blah, blah, blah. I'm giving names to meaning to the fields I'm passing in somehow. So somewhere here, instead of arg0 through arg17, I've come along and I've said arg1 equals true and arg2 equals false, or arg0 equals false, and arg17 equals whatever, length of blah, blah, blah. And I'm trying to say these args are lining up with those args, the names. So I'm building a named tuple. Oh, so if instead I pass a name struct in, that's actually the right. Oh, come on, quit that, Google. So I just make up a anonymous struct for my argument list and I pass it in, and then that's your names, right? And then the destructuring needs to decide, I'm going to destructure. You handed me, God damn it, Google, you handed me a struct, so I expect a struct. And I want to break it. And I need the paren, the add curly or not to break it apart? Maybe I don't. Maybe I say, if these names align, this is how I'll do the syntactic breakdown. If the names don't align, I'm going to give you a argument count error.
Right. And it's your destructuring, and it's just cheating on the destructuring, because one of our rules of destructuring was if you don't change the names, you don't have to say it twice.
You don't have to say it twice. Yeah.
So you just get this for free from the you don't have to say it twice.
Yeah.
But if for some reason I wanted arg2 to actually be a mutable thing.
Yeah, I have to say arg2.
Then I can say, yeah, I want. Plus, this gives me the advantage that parameters are sort of immutable by default, which is kind of nice.
All right, and
then function name to equals the structure name. It's quite a magic. It's agreed.
You arguing?
It's quite a magic, and the function name shouldn't matter how they're named.
The function's not changing its name, it's the arguments are changing the names. Like F is the function, the tuple follows.
The arguments, I mean, the alpha renaming should hold. But here, if you rename one argument of the function and pass a structure that doesn't have a name.
Yeah, normal means I'll do alpha renaming. And what you're trying to say, weird, W-E-I-R-D. Yeah, weird. That one forces named arguments. Because you're doing named arguments, you do not get alpha renaming. Like the rule is you get named arguments or you don't. Named arguments do not alpha rename as well, unless it's part of the standard unpacking syntax.
I mean, it's the kind of garbage you could pull. If I've decided that I have some name arg1 that I'm unpacking in my function.
Yeah.
My API says that name needs to be named arg2. But if I want to be like Bob equals arg2, I've changed the symbol inside my implementation, but I have not changed my API.
Yeah, that's part of the standard unpacking syntax. Right. So you get your alpha rename at the unpack.
Yeah.
Right. So I could rename my imports as I'm importing them, but I don't want to change the actual name because then I've changed my API.
Yeah, you don't. Right. And somebody does that. I've worked with languages that do that. And like they had stupid long names for many things that I happily, renamed something short.
What would the syntax look like to declare default values in the function signature? Or is that just declared in the method body or function body?
Right. I don't know yet. I don't have anything worked out for that. There's an obvious argument that says you just make another function which has all the defaults and you use one to call the other and you have two different functions, but that doesn't let you get all combinations of defaults without having to
What if you have a rule that says if I am building a struct and I give the struct constructor, I don't give this struct constructor a value, but that field is nullable, it defaults to null.
I do have one of those. Yeah, if you give me a field and you don't assign it a value, it gets assigned to null.
So if I define my function to say, I take in the struct, and you have to give me A, and you have to give me B, and C is a nullable int. And you just don't give me a C in the struct that you pass in.
Right, I see.
I'm going to get a null there. So you end up with a default argument where the only legal default argument is null, and you just check for those nulls.
That doesn't make, okay. That's not what I want, that's for sure. Like I'm claiming, or I think I've claimed that if I have arguments that come in, or I'm missing some arguments in the caller, but the function declaration, I have an expression, I will then evaluate the expression, and that's the value for the default. And now how does that syntax work? Because right now we've argued ourselves into, I'm using unpack syntax on function arguments,
that unpack syntax specifically does not allow function evaluation. In particular, if I have default values, what is the scope that they're evaluated in? Those expressions are evaluated in. Right? So there's no sensible scope here other than outside the current function I'm working on, in which case I should just declare them to be pre-computed constants or something. I don't know what the right.
So Python defines its default arguments as being evaluated in the context where the def is called.
Where the
it's so annoying when you inevitably hit the bug where you've put something mutable in your default argument and then you can't figure out why everything doesn't work.
Right.
So that's a different.
If I default this to be a list, it is the same list for all invocations of this function. And if you stuff something in that list, it's still there the next time you call the function.
Right. Well, yes. Right. You make a shareable, shared escaped list, and now it's everyone gets the hack. It's like you want deep immutability for default arguments.
Yeah.
Yeah.
But if I say my default argument is the result of calling this function, I want that function to run at def time.
When you say def, you mean at where the function is declared?
Yes, where the function is declared.
It's all anonymous functions, so they can be declared any fucking place on the planet. Wherever they're declared, if they have a default argument, that gets evaluated once, put into a hidden temp, and pulled out as a deeply immutable constant thing as the default.
Yeah.
Be sort of the desirable syntax or whatever, however that syntax would work.
It runs at the time and context where you declare the function.
The anonymous function, yeah. And people like to say fs2 is equal to, that's not the function declaration. It's the percent, the open curly, blah, blah, blah.
I say my default argument is a random 256-bit number. You get one of them. It will always default to the same number.
It has to be the same one, because otherwise you're evaluating code in some context, and they say, well, if I could evaluate the code and do what you define it yourself.
If you're defining a default value, it should be evaluated only once. If it's a function, called only once. If it's a
that's the question. If I have a default argument and the function is called a million times, do I reevaluate the default argument every time? In which case, why am I not just having F internally call the evaluator as part of its normal execution?
Which is what people end up doing in Python is my default value is none. And then I say, if value is none, set it.
And I'm okay with that. That's reasonable.
Yeah, Cliff, can you, have you been imagining allowing people to write their own, well, like in Scala, it's called an extractor. I don't know what you'd call it, but
scroll down.
The thing about the names, when you have 17 parameters and it's a pain to have all those, like, you don't care about 4 through 16. So and one's like blah, 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 to get there. In Scala, you can use an underscore, but you have like 20 underscores and it's annoying.
Bill,
what you can do, you can make your own extractor that ignores all, that has 3 things and sort of maps it to the 3 you care about. It's very
well,
remote.
that's how
you can get around it.
Unpack syntax will have, and all the rest, which if you don't name are just dropped on the floor. So
the dot is, I'll say that, if they're not named, they dropped on the floor. Yeah. I mean, that's one way to do it, but it's kind of, you can't, that if you take it out of the pattern position, it doesn't work as an expression position, I don't think.
I'm saying for what I'm defining for AA, I should be able to handle that problem by simply dropping it on the floor in an unpack. Do a tuple unpack of you. Somebody handed you a thing with 17 fields. You only want 2 of them.
Yeah.
Tuple unpack the 2 you want. The rest are dropped on the floor.
By naming them. That's
by putting them on a tuple unpack, which names them, yes. Which gives them a name.
Well, what I mean is like if the names are A, B, C, D, all the way A through Z is my names and my parameters, and all I care about is A, B, and Z.
So in the parameter list, you want to have a tuple unpacking syntax in the parameter list where I can say, and there's extra parameters I'm ignoring. Is that what I just heard?
That's what I thought you were doing with your
my opinion should be you have to index them. So like you index in the Scala tuple, if you say underscore 2 and 3 and 16, you get these.
That's a name.
So if I use tuple unpacking for parameter arguments, then you'll get whatever tuple unpacking does. If tuple unpacking has a convenient way to say and drop the 17 in the middle I don't care about,
than you do.
Hmm.
So right now, tuple unpacking has names and it has positional, and positional has no way to skip. But if you handed me 17 things and you want the function to drop the 16 in the middle, then we can go to named arguments, and you have to hand me 17 things in a struct. And the caller, who's already made 17 things, has to pack the 17 things he made into a struct, whereas the called function promptly drops 16 of them.
Okay, so the one thing that kind of I think, like, again, the higher level aesthetic is, if you look at what I can do if I have this thing I'm using over and over and over again that takes 17 parameters, a function I'm calling, and let's say I do this 100 times, and it's annoying that I don't care about these things. I have to fill them in. As I make a, actually, if I can define that function and put defaults there, I don't have to pass them in. But if I can't define that function, then I make another function, a separate function that takes 3 parameters that I care about, A, B, and Z, and fills in the rest. And then I call that one. So to do that in reverse for an extractor, it's called what you call, it's very verbose, compared to just writing a new function. But to me, that's sort of the way to solve that problem of, there's a whole bunch I don't care about, and it's very verbose to like
so that says
in a pattern, a bunch of names I don't use in a pattern.
Right. So
some way to make a new, like to destructure something that has 17 pieces, where I only care about 3 of them, actually like wrap it or unwrap it or something like that. It's the reverse of
how is that not just the the tuple destruction syntax we've been talking in the last hour? Isn't that just exactly tuple destruction?
If my tuple has arity 17 and I only care about 3 of the pieces, like in Scala, I have this problem. It's like a, case something a comma b comma underscore comma underscore comma
I hear you.
Comma z.
So I just said the answer was, you handed me not a tuple, but a named argument list. The caller went to the trouble of computing 17 things. You can fucking go to a little more trouble and get a name for each of the 17 things instead of just putting them in a tuple.
Right.
Now that he's got a name to them, I'm free to ignore the names I don't care about.
Yes. So what I guess I think Python does that, and it seems helpful, but it's not dualistic, is my point. Like the thing where the dual, to me, to name parameters when you call let's say call a constructor. When you deconstruct it, it's the names come out, not go in. So like when I say, I don't know, x, I call function foo and I say x equals, because it takes a parameter x equals 42. X has to be defined already, but when I have it in my destructor, that would be, in Scala it's x at, but what I thought we were doing was x equals, which is dualistic. It now pops out. I'm renaming this piece of the pattern x, pops out. So I like that. What Python uses that for is that x, Python uses it for.
Okay, someone is inventing a tuple syntax to pull out named tuple fields, which could probably work.
I don't like which sides of the equal sign those things are on, though.
I was trying to say this, just refer by the index you want to extract.
Yeah, that's not a bad answer. But my tuples are actually named fields, Bill. So I have names on those fields.
Yeah.
You have a tuple of 17 things. They have names, .0, .1, .2.
Yeah.
And I can put that in the field position.
Yeah. So you can avoid to.
Yeah, and you just have this a little backwards because you have to put the name you want on the left and equals the field on the right. So just say, B equals .16. Yeah. And that says you can hand me a tuple and I just want the 3rd and the 16th field out of it.
Yeah. That's my opinion.
Yeah. And that's identical syntax to named arguments, except I need the dot because 16 and 3 are otherwise just numbers. And we could argue that I can, in this context, I can tell I don't even need the dot.
In Scala, you add an extra underscore, but I think we can avoid it.
Yeah.
So I know it's just opinion, but I think it is telling that it was recently, right? It was .16 equals B. I feel like that is the more intuitive thing to say, draw the structure keys on the left and the bindings on the right. Obviously, either way works, but that seems to me, I know Scala, Bill, you were saying that already, right? Scala does that sort of a thing where you basically recreate the structure when you're declaring your binding form.
Yeah, and
it may just be me, but I think it's much more readable on two levels.
I know.
Of course, we are divided. It's a matter of preference. Yeah, it's opinion.
I'll say that again. Which one do you think is more readable?
I like the round parens and name equals then the destructure syntax, comma, name equals destructure syntax. And the reason for that is because in my head, tuple destructuring looks like a tuple, except the names are going to be exported out of the current namespace.
Right. Yep.
And adding
the problem is that .16 is a literal.
Yeah, well, it looks like a literal, but there's no literal assignment in a destructuring syntax. Right, literally the field name is 16.
.16 shouldn't be a literal.
Yeah, well, I'm saying the field, if in the parsing of the unpack, the rule on the right-hand side of an equals is I need to find a field name or a recursive unpack. The field name 16 is totally found in the tuple that I got returned. So I would even get rid of the dot. If I would do the simplest thing my parser would do, would get rid of the dot, and it would just simply take that next string up to the comma, look it up as a field name, got a hit, victory.
Fine, but it adds confusion. Someone would be mistaken for.
So the .16 gets a little closer to it's a field lookup, but it's still also like it's a floating point number 116 or whatever, right?
It can be mistaken. That's why Scala has this.
Oh, underscore .16.
It's
maybe. I claim the problem of destructuring a 17-element tuple and ignoring half the names is a rare one, and super special syntax for it is actually low on my list of problems to solve.
If I have to do it,
Clojure does if you have that you can use percent and a number as the sort of default arguments.
Yes. Okay. So there's another
just a specific macro, and almost never see that used in practice. I think people don't generally like it.
Okay, but that says that there is somebody else did a syntax. It's not used
in Clojure. The way that you pull an argument out of like if the way you pull an index thing out of a tuple is that you just use the number, like you call it like a function, and I think you can let me check, but I think you can actually destructure
as a runtime number. Like I could
let me see if it will use numbers for destructuring like this. It might.
Okay.
Yes, Clojure does destructuring at runtime.
And there's another version of that that says square brackets for array-like syntax to get the 16th element out of the tuple. I have to have a compile time constant there. You can't put an arbitrary expression, but you can put square brackets instead of .16, square bracket 16. Square, not.
Okay, this actually does work in Clojure, so I was surprised. I've never done it, but it works. So let me see. Let me show you here. To find the document.
And that's another.
That's unambiguous.
Where should I paste
find it a lot more readable?
Okay, it's not ambiguous because as soon as I saw the leading percent, I switched parsing modes. I am now parsing a destructuring syntax, and the rules are all whatever we say destructuring syntax allows.
That is an LL1 grammar. The percent defines what have to parse next.
Yeah. So, like when I do parsing of types, I say I have somebody's got a variable, I don't know what it is. It's an assignment, I don't know what it's assigning, : oh, I'm parsing a type. I switch parsers to parsing of the type syntax, right?
That's LL1 grammar. One token decides what.
Yeah. And I'm LL1. I'm recursive descent LL1. It's not quite LL1. There's cases where I go a little beyond the one, but basically it's LL1 parsing.
Okay,
it's super easy, super fast. Fine. And I'm hungry, and it's 12:30. we hit a live wire here.
Yeah. So I stuck the Clojure thing in here. I think you saw it.
Yes.
I think it's really nice to get the destructuring right, because you can get multi-argument functions that just fall out of it, and multiple returns that just fall out of it, and named function arguments that just fall out of it. And
there's a lot. Yeah, there's a lot of goodness.
It's important. It's important.
I'm okay.
Is Clojure the one that says b equals square bracket 16, or which one's? Oh, right there, the one that says Clojure.
Yeah.
One. Yeah. B equals 16 is AA exploring the syntax and pulling out the 16th element.
Yeah. So Clojure treats indexed like vectors as you can use it like a map, and the key is the index.
Can you explain that line of code like ChatGPT would explain it to me? The let A1 X colon X.
So let is doing a binding, and so the first square bracket is the destructuring, or it's the binding form.
Yeah.
And then the first the parenthesis the curly A1 is a destructuring statement. It's syntactically a map, and so the key the first key in the map is A, and that's what we're going to put our data into, and the value so just like someone was saying earlier, that destructuring reverses creation, and it's exactly what Clojure does.
Okay, good.
So
what is A1? What's the one?
Saying the one is the first index in the vector.
Oh, it's the index.
Yeah, or I could also give it a map with a key of 1.
Yeah, okay.
And so A is the value, and then the next square bracket is
essentially saying retrieve the first thing from A and then assign that to X, Y.
No, X, Y is data. So that's just two keywords. So they're like kind of intern strings.
Those are magical names that are used to represent the pieces that you got handed, the vector X, Y.
Yeah, think of it like a literal string.
Yeah, like this keyword is argument 0.
Let me change that just to take out one piece of syntax.
Okay.
So this is a vector with 2 strings now.
Okay.
Yeah.
And I'm going to grab Y out of it because that's at index 1. So that's this is going to pull this Y out. And then A is what I assigned. And so this is the end. This is the binding form.
Yeah, and then you say A is the result, which is it's going to be Y.
And the result of this statement is this Y.
Okay. Okay.
I almost got that, but I didn't.
Okay,
I'll
go through it one more time.
Program being evaluated under the let.
Index.
Yeah, so let is the statement here. Let bind something and then return A. And so here, this is the overall binding form. Here's the first binding destructuring expression, and it's saying A is the value I'm assigning to, and here's how I'm selecting it.
Okay.
So it's 1, and then here's the data that I'm using as the input to the destructure.
Yeah.
And it's 0-based.
So that's a vector, a 0-based vector.
Yeah.
And so Y is at index 1.
And what's the A to the right, the next A?
What?
That's the return value.
Okay.
Yeah.
Okay, so
once I'm done doing the let to do all the binding, I then evaluate A in this new context that I've just let it up.
Yeah. So
I see. So the let ends at the closed square bracket.
Yeah, that's right.
And then I'm just saying A is my result of my.
A is the program you are evaluating.
Result of
now that you've bound
that parenthesized expression. So the first part of that parenthesized expression is the let, and then I have A.
Yeah, exactly. The A evaluates to the string Y.
Yeah.
So I don't know if this makes it
that makes sense.
confusing.
Yep. No, that makes sense.
Okay.
I don't know what the
I have
double.
a question. So what if you wanted to also bind like that? Like if you had a second value for if you wanted to pull out a second value from the list, how would you do that in Clojure?
I could say B0. And then I could return B instead. Or I could append A and B. So that would be XY. That would actually be YX.
So I tried some AA syntax, which just said, take the thing on the right, put it in the underscores, and do array destructuring. But I can do tuple destructuring.
Okay, so
directly.
Eric, I think you said that Clojure is doing the thing where you can take it outside and then it works as an expression. But what about A1? Does that work? Can I do that in expression land? Does that have a meaning?
Well, yes, because you'd reverse it. And so if I wanted, I could have 1A, 2B, and as long as A and B had some value. So if I say, oh, sorry, 0. Right. So if I say let A is Y and B is X, then I can return a map of key, right? The key 1 is A and the key 0 is B. So it's not exactly equivalent because when you're destructuring, it can treat a vector as a list. So this isn't how you would normally destructure enclosure. Let me show you how you would normally do it, because I think it might get confusing. You guys wanted to see how to do the index destructure. But normally what you would do is just say BA like that. And that's a positional destructure.
Yep. But you can do the indexing one like you showed there.
Both of these work, yeah.
One, two. And when you do the indexing one, like let's say it's A through Z actually in the structure you're using, and I'm ignoring C through Z, and that's okay. When I do
like this.
You're saying
well,
you have 26
26 of them. 26.
You got a big old list.
Yeah.
Oh yeah. Yeah, that's right. So however many things,
right,
that would work fine. But it would also work fine here.
How would it work fine in that case? Because I've only got 2, it just says the first 2 and forgets about the rest or something.
It just forgets about the rest. If I want to capture the rest, I can say whatever, some name, more.
Yeah. Right. And use the and sign to say the rest.
Right. Okay.
That's right. That means the rest. Yeah.
As opposed to dot, 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 which is also.
And the interesting thing is that I can have another destructure in here.
Oh, yeah. Okay,
yeah.
Sure.
List.
Yeah, right.
So actually, I think like the dot, 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 to me, that would work if I want to ignore everything from C on. The problem is what if I want A, B, and Z? And I don't care about the others. That's what gets annoying in Scala. And
you want to grab the last thing?
I would actually ask.
Yeah,
is that necessarily a bad thing to deliberately cause developers some pain if they have really long lists of arguments? Because at some point you want to say, hey, you know what the solution to your long list of arguments is? Name the arguments. You shouldn't take 27 anonymous arguments.
Right. Yes. Right. I'm there.
Well, even if you name them, like in Scala, if you name, it's not a tuple. It's, very nice names, very beautiful, 26, very elegant and understandable names.
Just do name structure
by position.
Like name structure destructuring on that, right?
Well, you can't do that in Scala.
You can't just,
no,
I see.
It's always by position. I can call a function with names, but I can't deconstruct
You can't,
it.
okay, I see.
Can in Python, I think, but I was looking for the syntax to make sure.
And AA, I'm claiming I'll get there.
Here it
where
is.
We'll do named field destructuring. I like that, and
there it is. Yeah. Oh goodness, I got a nice code example here.
So I threw in your example where you want to grab Z.
Yeah. Okay.
And
yep.
So
how did you do?
So
that?
you could. It's an indexable structure. So assuming that I didn't already have access to data, which I do.
That's a runtime.
How about if I want W? But okay, you get that's good. I like it. So that's the thing, though. I can't on that second line, like 2 down from. Well, I'm not sure which one's your cursor. 2 up from you. I think you're
this one, which I just highlighted.
1 above it. No, the one above it.
This one.
No, I'm sorry. The BA ampersand that one. See, I can't write there instead of say ampersand rest. I can't say I just want to say BAZ. And ignore everything else, and I'm really saying BA and then everything
last
else.
Rest.
And then later I
just you can't grab a last thing in destructuring.
So in Python you can. I can close that code out. I think it's my
statement.
code. So I asked ChatGPT, but he came up with it because I thought I remembered this. Oh wait, I'm looking. I gotta go to the doc. I'll get there.
Yeah. So like Python, you could do like if we had sort of crossed closure in Python, I could say -1 here, but you can't do that in closure.
Right. That's interesting though. Yeah, right.
Okay. Can we the extension can we do the extension?
Oh, do the extension thing and then lunch. Like we were well past lunchtime here. All right, I'm gonna moderate ourselves to end this. What are you trying to do with the extension here?
I'm not proposing, but just theorizing some syntax to enable to move the delete in the to call it like a method. It's like an extension. That's you have to play some kind with the syntax to know that to import really, to know that you will need the hash table in order to call this method, and instead call it like this and pass them my hash.
You want to add a method. You want to add a method to hash table. Is that okay? Yeah. So in my head, that turns into subclassing. I have hash table with a delete instead of just hash table with put and get. And I want to make a new hash table, which is an extension of the old hash table, which I'm going to do by throwing a syntax on. I can do this with the types. I don't have this on anonymous structs yet. But I have a syntax for the thing in question here. So I'm going to go write some syntax. It's not your syntax. That would be the existing hash table as a type, which I don't actually have, typed as that, whatever that type was, plus now delete equals to, and it's in the scope of the original hash table. So the colon says I'm a type. I'm basing myself from a prior type, so I'm an extension. The prior type is hash table. Here's my extension. It has to be a struct because types in this case are structs. So I'm just going to add another field and the field does whatever it does. And it has full access to the, it's in the scope. So it has access to the key and can just call the table.remove, whatever.
Oh yeah, we'll talk about this.
I think in the way past, I haven't implemented this, but it's sort of the right direction I'm heading.
It's a little bit scary in that you may have just broken your ability to use closures as a security mechanism.
Well, I would claim that it was never my intent to use closures as security. We could argue I should do that. Instead, I was going to claim I have a security thing specifically to do security. And we could argue that
because the minute I say extends encryptor, this is my extension of encryptor that is an encryptor that gives me the keys.
Right. Yeah. Right. So in this particular context, I've broken a bunch of rules, so it doesn't actually work. If table is inside the struct and not in the closure, you get an exposure to it. If table's outside the struct, I actually can't access the table, so I can't call table.remove. But I can call internal fields like put, or however I do a remove. I can call the API exposed by the at struct put and get. But I can't actually get at the table. Because that it would in fact go back to the closure hides, right? And I'm extending the at sign. And I haven't decided that I'm going to allow you to anonymously extend an anonymous struct, and maybe I will. I think that just falls out fairly straightforwardly. In which case, maybe this works.
I don't have a problem with extending structs as long as it doesn't break the closure.
And then the rule on security is use a closure for hiding, and here's how you do it. Yeah.
Because if closures actually work for isolating things, then
I think
building object capability systems in your language becomes
I think closures
more obvious.
Have to work.
Okay.
And it depends how you expect your language to be used. So like Python, the closures are very weak, but that's because they don't expect you to be running malicious code in the middle of your Python process.
Right. I'm under
Whereas JavaScript, you want your closures to be much stronger because people do totally expect you to have imported some random JavaScript from the internet somewhere and run it in the context of your web page.
Yeah, no, I'm under the theory that you should be strongly good, well-typed lambda calculus closures, which will be strong and not have holes in them. Yeah.
But if you cannot access the table here, how can you write a method that works with an internal state here?
You cannot. That's the point.
That's the point, and you limit the extension ability.
But on purpose. You have designed a structure that is intentionally limiting what I can do here. You have designed a hash table where I'm limited to the original API. If I want to have a hash table where I can hack it internally, I have to expose table. So then I have to move table one line down, and now I have a hash table I can go.
Okay, now table is private, and you again.
Yeah, in Java, I would say private. I've got a private table, and I want to, what can I do with a private table? I cannot extend, I cannot subclass a Java method, a Java class, and access the private fields.
And then the point to add a method after the fact is to add it without relying on the implementation.
That's yes.
You add it just like you would define it, or you add it like when you're defining the class. And the extension here is limited.
This is, I added a function to hash table. It's a convenience. It uses the existing API and can only use the existing API. And there's a different hash table that I could define where new extensions can hack the bejeebers out of the table.
Yeah, but you rely on the fact that some things are private or some things are public, and the extension method has to conform what he can access.
Yes, yes. On purpose, you're allowed to define a guy I can't usefully extend. You want to shoot yourself in that foot, you're allowed to do so, but you should be allowed to have a guy that's secure, and I cannot extend except by as if I called his normal API. I think that's entirely fair.
Is that meaningly different than just having a sort of splat? Hey, I'm making this new thing. I'm starting my new thing by throwing all the stuff that's in the old thing in it.
All right.
I mean, if you make a new guy, that's a new guy, it's a clone of the old guy, you do. And somebody who wants to be secure won't take your new guy because he has no relationship to the old guy.
Right. So the line that I drew right under your hash table syntax.
Okay, I don't see a line. I have highlighted. I don't see any lines.
Yeah. Thing is that even if
I have that, I say I want to take everything that was
tables.
in this struct that was hash table and throw it in the struct I'm building right now, but I also want delete.
Yeah, this delete uses the API from hash table as a delegation. That's fine. You want to have a new version of delete that does something to the table directly. It doesn't put a 0 for a key as a delete, but does an actual removing an element from the table. So he wants to hack the table. So here I'll give you you've redefined hash table. Yeah, new hash table, thank you. Now you have a delegator of an old hash table. That hash table never exposes table. You can't hack it. So you can't just say, I got a delegation to a hash table, and then I'm going to hack the table internally. I actually have to copy.
Is that different than the thing above?
Yeah, I have to copy the code. And now I have an unrelated, no, it's not, one of them is inheritance, one of them is delegation, and then there's just clone the fucking hash table code, move the table, make it public. Right, the delegation guy is a new thing, never before, behaves like a hash table, but it's not really inherited from a hash table, it's just forwarding. And so it's as secure as hash table.
Right.
The extension is as secure as hash table, and hash table in this diagram is actually pretty secure, and you're not allowed to hack the underlying table. You only can get out the API.
New hash table dot put and dot get, it's going to mutate the same underlying table.
It's going to call the same hash table, which will be the same underlying table, but you can only do puts and gets. But if all you want to do is puts and gets, then you can do them, and that's fine.
By the way, if you want to have both, you can easily do that by making table be an argument to your hash table function, and then you can have one where you've hidden the table away, and another one where you put it out in the open.
No, that's what I'm saying. I mean, I basically have that's the discussion here. We've got the table being public or private. If it's public, I can share it about and hand it to other people who can surf it for what they want. They can remove entries, and they have a freely hackable array.
Yeah, but so you can basically have both flavors by having a hash table implementation, which is another function which takes the table as an argument, and then you have this hash table which has a private table and then calls hash table implementation, returns that, and the table is closed away forever.
Right. Yeah, I understand. Yeah.
And you can also have an open hash table where
public hash table. Yeah.
You return a structure where you've added the table right into the structure or whatever.
Right. So hash for table itself, I would just take table as an argument. And then there's a public hash and a private hash table. Well, this one is the public one, actually.
Yeah.
And this is just going to call public. Oops. With the table on the spot here. And now the last instances of the public bracket 7 bracket got passed in and I never see it again. And now I have a private hash table.
Yeah.
Yeah. And if I clone 7 earlier, then I did.
Exactly.
Right. Yeah.
So you can kind of have it whichever way you want.
Yeah.
With this structure pretty easily.
Yeah. All right.
Makes sense to me.
Once again, I'm want to call it here on the late night compiler show.
Thank you.
Oh, I just wanted to shout out a paper. So I put it in the links section. There's like, it shows that underscores are better than camel case.
Oh, that's easy. Everyone knows that.
Yeah. So like,
snake case is even better.
Well, that's what snake case is underscores. If you're talking about
okay, wait. I'm going to hand you both knives and lock you in a small room, and the winner will determine which way you have underscores or snakes.
That's right.
No, we're done this week. I'm moderating. We're done this week. Save snakes for next week. Camels and snakes can have it out next week.
And kebabs.
Kebabs of camels and snakes. I don't know. Maybe. This sounds very Middle Eastern.
I was gonna say a camel kebab sounds good.
All right, gentlemen. It's been good. It's been fun. It's been long. I'm done.
Bye.
Good
Bye.
weekend.
Bye, guys.